It is such a pleasure and an honor to be in Stockholm. And I'm Ilya Parker. And this is going to be a little bit of an unusual format, but I want to do as much cultivating the intelligence in the room as possible, because we need all the brain cells possible, all the intelligence possible to be cultivated for creating the safety that we need when it comes to tech. And AGI is no different. So this is the building we're in right now, here at the Digital Futures Center. And we are all intelligent people, or we think we are, and other people have validated that for us. That's how we got here. As a general format, I'm going to put thoughts first and people second. We've heard some people using the phrases of democratizing AGI, or certainly when it comes to safety, oftentimes we think in terms of, well, if that machine is smarter than me, what could it do to me? And putting people first is central in that question, but often, how do I know that I'm going to be safe if something is smarter than me? We want to put the ideas first. So an example for myself, I'm in the room because alignment is an area of specialty for me. It's something I'm passionate about. So is making rational plans for irrational actors, such as your average human being. So that's my ideas that bring me to the table this morning. And my name's Ilya. Okay, there we go. So roughly this morning is going to be structured with some talks in the beginning. We're going to do a panel for the second hour, roughly speaking, and a lateral discussion for the third hour, roughly speaking. So that's the most general outline of the schedule for this morning. The idea for an unconference, I was introduced to it at Harvard. I took a peek at Wikipedia. Harvard was one of the first places where unconference was coined as a term, though the idea extends back further from there. The idea is to kind of invert power structures. It really is great for creative thinking and for democratizing knowledge. So thanks for your patience. If you're new to the concept, I am going to be very loosely basing just mostly the idea of how do we invert power structures in a conversation, not just to create equality, but to create a higher quality of intellectual content. So for this first section, we're going to have some impromptu talks about where safety is at right now. So everybody gets an idea of what conversation we're having and how it's different maybe for AGI than it is for other areas of tech or for other more narrow AIs. We already have one volunteer who's going to be sharing his ideas. So I want to say thank you very much, Tyler, for starting us out by volunteering to unconference this morning. But before we move on, the most important part of we this morning is you. So we're going to take 5 minutes. I'm going to be the timekeeper. Good morning and welcome. I'm so glad you're here. So everyone, please stand. This activity will be over in 5 minutes, whether or not we're done, okay? Oh, great, thank you. So do not sit until instructed. We're going to hear a prompt, and when you have a word pop into your head, a free association, you're going to raise your hand. Okay? Everybody ready? You got it? In relation to AGI, what word comes to mind first when you think of safety? Okay, So hold on to your word. Hold on tight. You don't have to have a word, but most people do. So I'm going to move to saying, what is your word? All right. So, what is your name? Oh, nice to meet you, Emma. Okay. Is that how it's spelled? Awesome. I grew up with an Emil. I used to babysit an Emil. Anyone else have the same word, predictable? You can sit down, Emil. Anyone else have predictable? No? Okay.
So understandable.
Anyone else have understandable? Don't forget what you do have, okay? And your name? I can almost see it there. T-O-M. All right, what's your word?
Don't.
Don't. All right. Did anyone else have don't or understandable? All right. Thank you, Bob. I am actually going to go ahead and say, I'm going to go ahead and give it that distinction of being separate.
Detached.
Okay, can I have you pass the mic to the next person at the time?
Of course.
And your name?
Alignment.
Okay, anyone else have detached or alignment? All right, what's your name? And which was it, detached or alignment? Okay, how do you spell that? M-A-T-T? Simon? All right, I'm pleased that we have one thing, one point here that is shared.
I thought of security.
Any other for security? All right, going once, going twice.
I'm Felix.
Thank you, Felix. You want to pass the mic?
My word was, I was prompted here, but my word was people.
Yeah, I love that. Thank you. Anybody else with people?
Waste.
Waste.
Peter.
Thank you, Peter. Anyone else with waste?
My word is misunderstanding. The name is Pei, P-E-I.
Assurance. Habtom. H-A-B-T-O-M.
Is that what I heard? M. Okay, thank you. Anyone else for misunderstanding or assurance? Welcome. We're just saying the first word that pops into our minds when we think of safety in relation to AGI. So you with the camera, what is the first word that pops into your head when you think of safety and AGI or tech? And so there's four things that pop into my head. Fair enough. It is optional. It is optional. All right. We've moved from free to red, so I'm 30 seconds over time, but we did pretty good until that last thing. Yeah.
I would be going for governance.
Oh, governance. Thank you, Peter. Oh, what was the last one I heard? And what is your name? Oh, can you spell it for me? Like rain. Well, okay. Where I'm from, this would be Rainier, and there's a mountain, Mount Rainier, if you've heard of it. Oh, really? You learn something new every day. All right. So this is some of the ideas that we're walking into the room with, and we've got the next several hours to get as many ideas from each other to expand what we already know in this community and also to push further beyond that. So if you already think that you could talk for 3 minutes with pretty informed talking for 3 minutes on safety and trustworthiness, please raise your hand. Okay. If your hand is up, write your name on a piece of paper. The one that I've already handed you. So if your hand went up, put your name on the piece of paper, the little one, and then we're going to stick it in the bag here. Yes, please. I think a lot of people are, oh, sorry, I better go back to slideshow. I think a lot of people are thinking about the ideas in those books. And so this is, if those are the ideas in your head, absolutely. Absolutely. So it is really intelligent to ask questions about, so if, yeah, so this is about cultivating expertise. There actually aren't any safety experts in AI currently. So we can't call the experts into the room that do not yet exist. I am creating them right now. You see them next to you. It should scare you. Okay. All right. Where's my pieces of paper for those who have at least 3 minutes of confidence? All right. Thank you. Thank you. Any other takers? Oh, thank you, Emil. Wonderful. Okay. I need an innocent bystander to do the picking of the names. You, sir, are up. Thank you.
Just pick one.
Yeah.
All right, let's go.
Oh my, oh my. I didn't rig it. You saw that, but this is my coworker. So so what we're going to do is each person, let me I have that slide back. Each person can have 3 to 18 minutes. So what I'm going to do is ask you what amount of time you would like to have. Okay. And are you going to connect to the Zoom room or are you going to just talk? All right. Are you connected to the Zoom room? Excellent. And you'll go second. Okay, awesome. So a big round of applause, please, for Tyler, who volunteered to be who was our first volunteer. So I'll forward you the link. I'm going to hand you the mic. I'll just show you the time as it gets lower.
Can we stop sharing and I can start? Okay, so I just gathered some of my slides and my background is in systems engineering. I have a PhD in systems engineering from University of Virginia. And I'm heading this lab, responsible general intelligence, purposely not called safe general intelligence. And but there's just three points I thought maybe I could add to discussion. And the first is that we can model learning systems at an abstract level, so we can start to engineer them without knowing exactly what the solution method will be. Of course, the solution method will be critical, but I think that's part of it. The second is that it's not just about the learning system, and in those cases where we can't test it, there's some support systems around it we can. And the third part is kind of this challenge problem of trade-offs between safety and trust over the life cycle that come with trying to maintain learning systems. So I'm talking about learning systems. I realize that's not completely, that's just a facet of AGI, but just add to the conversation. So here's myself. I'm really after these first principles for engineering AI heavy systems. And the idea is AI heavy systems is just one where the main factor in being successful is the AI factor. And just to kind of scope the talk, I'm really talking about systems engineering research. So not necessarily the formulations or the pure mathematics, but also not really the AI engineering research, which tends to silo things into like the pillars of AI. So of which safety is usually a pillar and trust is a separate pillar and so forth. And those pillars really don't rise to the level of actual engineering processes that you could follow to realize a full system that meets some stakeholders' need. That's the systems engineer talking, but that's why I have the system engineering V. And I'm not going to evangelize about the V, but just that this question of what are the engineering processes, if we treat safety as a property and trust as a property and all these things as properties we'd like to have our solutions to have, how do we go about in a systematic way trying to engineer that? And so for that first point, modeling the systems, I take a systems theoretic view that a system is a relation on sets, which is no different than saying the system is the whole formed by parts in their relationship. And yeah, when I was defending my thesis on the related topics, one of my committee members said that general systems theory is one of the most interesting and useless theories out there. And I do think it has some use in this field because we're after similarly general things. So systems theory is largely a theory of sets, and learning theory is largely a theory of probability. So it just measures on those sets, and then machine learning typically just adds a bit of algebra on top of that. So there's some intuition that in contrast, like something like biology, once we go from systems theory to biology, we lose a lot of detail, but I don't think that really happens here. So just formalizing it at a high level, systems can be represented as the learning system can be input output, like it just takes in data and so that later can take in some inputs and give some outputs. At a deeper level, it has a cascade connection of a learning algorithm and a hypothesis space. And then we can start to add detail to the algorithm. And there we find some issues, right? Where, because the search problem is kind of a closed subsystem where the inputs to the objective function or the outputs of the search function, and we can't, I mean, there's a fundamental black box nature. So that merges top down from systems theory. And yeah, and so there's the model, and there are the terms for those different things. And so at this high level, we can start modeling these systems. Like supervised learning is just a constraint on the data typically, that it's labeled, and unsupervised learning is that it's not. And for learning theory, empirical risk minimization can be specified similarly, except we have to specify the algorithm a bit more. And so that's really just the first point. And as it relates to safety and trust, a lot in systems engineering, we have processes like the stamp process and so forth for traditional systems. And the idea is if we can model these learning systems within at the same level that model the learning systems at the same level we model normal systems, we can start to reason about how they're dependent on components and what are the key interactions and so forth. And by staying at the abstract level, we can start to do that while, say, engineers are still building the solution methods. And certainly if we're looking from the point of view of the owner of a system who might be exchanging solution methods over time, but wants to maintain safety, this kind of thinking could be helpful. So that's the first takeaway. And the second takeaway is that's really this input output view that doesn't consider, that follows the traditional systems engineering of we have a big system. It's really like this big input output function, and we can break it down to components. And if we can get those components right and recompose them correctly, then we'll have a system we like. But of course, learning systems are meant to interact with their environments and change over time. So normally we have this machine learning pipeline mentality, and some people maybe think we can add trust as a metric within the pipeline or something like that. But my challenge to that is that the machine learning pipeline is just looking at that individual component. It's not looking at the whole system. And some people say, okay, well, what if I put the ML ops pipeline within the DevOps pipeline? Then it's looking at the whole system, but the whole system's not just the software. And so the little diagram I have just to emphasize that is once the model leaves the training pipeline, we have to integrate that. And maybe it's integrated when it leaves the pipeline, but maybe not, especially if we're switching between platforms. Maybe there's some deep neural networks that need to be quantized and so forth. And so that's a challenge. And then we actually put it in the real world, and that's the first time we get genuine feedback. When it's there, we actually have to observe it. That doesn't come for free. That also might not be purely software. Observing the inputs and outputs might be a hardware kind of harness, but more importantly, actually looking at what are the outcomes of using that learning system in the environment is a whole nother thing, right? And might involve people observing it and other things, right? And then there's these two feedback loops, the shorter term, like quality control, how do we detect unintended consequences, which is certainly important for safety, but then also the re-engineering feedback of the idea that we figured out something more about the requirements or the scoping of our system, and enough that we can go back to the training pipeline, maybe resample the data. But for an engineering process, we might actually have to go back to like contracting. I mean, consider that the party that owns and operates the training pipeline might be different than the party building the models, the learning systems, is probably different than the party that's operating them in the real world, which might be different than the party that's responsible for testing them and observing them, and so forth. So you have all these different groups to coordinate. And the point here is just that, as we go around the shoulder of the learning system and look at this, there's a lot of systems that it engages with. And it's probably the case that we can't really know what the AI is going to do. And as it gets more intelligent, we probably shouldn't know what it's going to do. Or if it's too predictable, too understandable, maybe it's not that intelligent. So the point is, we can test these other processes. We can have high confidence in the safety and trust, maybe if we understand that it will be integrated appropriately, that we do have ways to observe it, and we can measure how long it takes to get back to the training pipeline all the way back through, but as well as the presence of fallback systems and so forth in that shorter loop. So ideas of resilience and resilience mechanisms as being a way to take the burden off of the learning system itself and put it onto the rest of the system. So that's a second takeaway, that there's these processes over the life cycle that definitely affect trust and safety, and over the life cycle of the models, because we don't anticipate to really know how they're going to behave at first before they say solidify into their roles. It's often easier to test those things before we deploy. So the last point is just a higher level point, something I've been thinking about, but it's kind of obvious in a sense. But from an engineering perspective, we usually think about products in terms of lines and families. So I have a production line here for BMW, and you see the blue cars, maybe that's one product line, and you kind of see a white one in the back there, maybe another product line, and together those form a family. And one of the main things in engineering about doing this from a safety and trust, well, from a safety perspective, is the reliability testing. So if there's 1,000 cars out there, maybe I can just pull 30 of them, and that the statistics about those 30 will tell me something about the whole population. But the learning system should engage and kind of intertwine with their environments and with their users over time. And so as a result, I can't just sample 30 out of the 1,000 to understand what those 1,000 are doing. And so that leads to this mental model of maybe not families, maybe it's more like herding, where the idea is these things are going to sort of go off in their own direction. But if we let them go too far, they're all too idiosyncratic to really have some kind of top-down, say, governance or management or otherwise. So there's this trade-off of, well, to optimize to their users, to their environment and their specific roles they play, we have to let them individuate. But at the same time, if we let that go too far, we lose the ability to really top-down manage them, which if we're building an AGI to be independent of us and just sit next to us in a conference like this, maybe that doesn't matter. But in the case that we really have this engineering purpose of what we want to do with it and to sell it to somebody, this is a problem. So then that movie Blade Runner 2049, I think a good example of this is the virtual girlfriend that you know, the protagonist, well, I don't want to give spoilers away, but I'm going to end up doing it. You know, the protagonist builds this bond with their virtual you know, girlfriend, and as you can imagine, if they factory reset your virtual girlfriend, that's a big problem. And there may or may not be a point in the movie when they do that, and it may or may not be traumatizing for the protagonist. And so it's just a simple point that you know, herding is maybe something you have to do to actually have these things get better of the life cycle, because many of the things that they need to do won't be known until they're in their environment. And so that's the third point, that there's this trade-off between safety and trust, because if I can do the factory resets, then I can have good models of, you know, where they are at all times, and I can re-baseline them quite easily and so forth. But at the same time, maybe when I do that, I'm losing the trust of the users. So it's a delicate balance to consider. And I say maybe a trade-off because there might be solutions to that, but I think it's certainly a challenge to this traditional product families and product lines. So the last point is just a kind of abstract road mapping of where I think this matters more. With machine learning and the basic stuff we have today, I think this open systems approach of just the functional decomposition is pretty straightforward, especially because a lot of times the models are frozen and so forth. As things get online and there's more learning going on, then then we have to consider some of these close factors. I think it matters a lot more. And ultimately, once we get up to like AGI level stuff, I think it's mostly that closed system factor that matters, because there's a certain complexity inherent where we can only decompose so much, and most of the factors are more about the engagement with environment than anything else. So that's some opinions and just brief thoughts. So thank you.
Thank you so much for kicking us off and for sharing your really lovely insights and your coherent thinking. I appreciate the takeaways. Well, you can take a seat if you want to, but I'd like you to stay here because I think there's going to be some good questions, and you don't have to answer them, right? There are really no true experts yet in safety in this area. So, but I'd like to collect the questions, and I'd like to give you an opportunity to comment on those you choose to comment on, right? So,
yeah, looking at these charts or schedules, I come from software development. Yeah. So in software development, we have typical what's the name? Cycles. Yes. So there are stages, and there's like preparing the requirements, then so to say implementing, then testing, then releasing, and it goes in a cycle. So I would say this is yeah, the question is if you think it is similar in ML or in AI, it can be it can keep like this, like a standard software development cycle, or this here needs to be considered somehow, especially because of the security reasons, or because there in software development, I think we have a very good control over everything. Yes, we mentioned DevOps, and so yeah, from my standpoint, well, I see if there are any problems, then I see it in some different places in terms of security. Yes, not just in a cycle or in designing the solution. Yes.
So the question is, so the question is, how do I justify this being of interest? Or?
Yeah. So the question is, if you think that in machine learning processes, so to say,
yeah,
has to be considered differently than standard.
Okay. Yeah. Sure. So what's different than software and machine learning? So depending how you differentiate these things, I think there's some basic differences with software. Like many times, especially if it's safety critical, we can get to the point where it's nearly deterministic. We can even use formal methods maybe. People go as far as developing assurance cases, like really strong arguments. And that happens as you go through that process multiple times or through one big waterfall process or something. Oftentimes, maybe it's based on the requirements as well. But machine learning is more stochastic, right? By its nature, maybe there's some variability and we can't predict. And as it gets smarter, maybe we shouldn't predict it either. So I think there's some stochastic aspect that can be a bit different, a bit more challenging, and can put some more emphasis on the parts other than the software to support that, right? Because if we bound the stochasticity, then we don't let it like make guesses to try to learn over time and stuff like that. Also, there's the data inadequacy of the fact that many times we won't have the data to know or test these systems. We'll be deploying them in new environments or changing environments and so forth. So a lot of software, we can do coverage testing or fuzzy testing or what have you. But in machine learning, it's really vague what that means until you have a lot of data, because you're looking maybe over coverage over the environmental states or the user interaction, some description there. I don't think it's that the process has to change, but I am definitely arguing that we have to look beyond software when we think about something like safety and trust, in that these AI will be embodied and we have to consider that as part of the thing, part of the system. Now, maybe there's a world where if you get the software right, everything else is trivial, but I think these challenges are pretty hard to get across if you only look at software. Another way to think about that is even with the systems today, if we have a dozen different machine learning functions, like in a self-driving car, now they're starting to interact with each other too, right? And so when we engineer them, we have to consider that interaction. And if we just have one MLOps pipeline for each of them, we don't really see that. So I do think the systems view is important, and I think it might also go beyond software.
So much. Thank you very much. That was awesome. If there's any other questions, I'd be happy to write them down. Yes, go ahead.
Okay. Do you think that we should somehow find processes how to train models, how to certificate data sets that we will, I don't know, kind of ISO or other certification for models for data sets that, for example, because of course you can have trustworthy model working, but then if you provide garbage to this model, you have garbage again. Yeah. So it's not only about the model, it's also about the data and whole training process. Do you think it's reliable to have something like that? Should we find solution how to, I don't know how to name that?
Well,
all right, no, you're off the hook. So I'm going to be a strict timekeeper, and we're going to hold the question. I have it written down, and we've got 3 hours. So that definitely will go to our panelists and in other discussions also. So thank you for asking. While you are setting up your computer and sharing your screen, I'll record any other questions for this. Yes, please go ahead.
One of my questions is, like, I get what you're talking about with a learning system and the differences between sort of a traditional software system and a learning system. But I also wonder whether the intentionality of advanced artifacts are going to change. You know, there's a difference between an autonomous driving system that's learning over time versus, you know, something with much more intentionality, like your Blade Runner example, right? And so it feels like that maybe there's some distinction there that will have to be made over time, because how you define the bounds for something with intentionality and stuff is going to be very different than I think what you would say the bounds are for a learning system.
well, if I could just make a short comment, is I'm happy to stand on the side of the systems engineer to provide that viewpoint, but also in the talk I gave earlier, my whole point of building up the open systems is to say, actually, maybe intelligence is this thing that dissolves system boundaries over time. And so we have to identify, for example, those core mechanisms, which we don't expect to change. And we can do our safety assurance and stuff around that. But the other stuff, we have to have a risk viewpoint. So thank you.
I love how awake this room is. And we will be getting back to those. So here we go. Without further ado.
Thank you, Ilya. Yeah, my name is Ramesh. I'm from the Naval Research Laboratory, and I work on AI safety. Contrary to indications that there are no AI safety researchers. I'm trying my best to be one. And so how many people like to use AI in weapon systems? Show of hands, please. One, okay. How many do not want AI in weapon systems? Okay, okay, so it seems like some of you are just ambivalent about this. Abstain, okay. So what if I told you that the DoD just released a roadmap in January about AI in weapon systems? Have you guys heard of 3000.09? How many of you have heard of 3000.09? Okay, one person. Okay, so people say, oh, AI will never be used in weapon systems. This is crazy. This is nonsense. Well, this is a publicly available report. It's called DoD Directive 3000.09, Autonomy in Weapon System. And the recent update to this on January 25th, 2023, talks about using AI in weapon systems. It's an AI update. And this document is more than 10 years old. It was originally published in 2012. And now in 2023, there was an update, and they want to use AI in weapon systems. So what is my job as an AI safety engineer? Is to tell people not to use AI in weapon systems. Okay, that's what I do, right, for a living. Okay, all right. All the hazards of not using AI in weapon systems is what I tell people. And it's a very tough job. And why do you think this is? Why do you think it's such a tough job of preventing people from using AI in weapon systems? Is because of the top-down push. So everybody wants to use AI, right? Because otherwise we'll be left behind, and the Chinese are going to take over and do a lot of stuff. It's the FOMO. It's called fear of missing out. Okay, so they're being pressured. The actual program managers, the people who are building systems and so on, are all being asked by their management, why aren't you using AI for this? Right? Although the idea here is just to say that I'm using AI, it doesn't really mean that I'm actually going to use it. So I'm giving them tools to stop them from using AI, and at least some argument against the use of AI in weapon systems. And so that's what, so I'll start off with, aviation industry. So I work very closely with EuroK and SAE, NASA, ESA, FAA, and so on, who are the regulators of AI, right, in aviation. And so you want to make sure that the regulators at least understand the hazards and pitfalls of using AI willy-nilly, right, without really giving thought to processes. So, okay, so this is me, this is my, bio. So essentially, I'll try to define the term autonomy. People, for different people, autonomy mean different things, but it's the term to describe an automated system, including, perhaps the use of machine learning for their operation. Does Tesla use machine learning? Hell yeah, yes. They have a neural network, for object detection, classification, segmentation, et cetera, right? So there are neural networks all over the place there. And so very scarily, European regulators are saying that every single car sold in the EU, starting in 2024 or something, should have AI for traffic sign detection, speed detection, lane keeping, et cetera. And by default, they have to be turned on every single time you start the car. And you can turn it off, of course, by going through some, very complicated menus. And if you don't turn it off, then it's going to go do lane keeping for you. It is going to change, look at the speed limit on the Autobahn, and then it'll change the speeds for you, et cetera. And I actually tried, using a Volkswagen Golf on the Autobahn. It was a disaster. I mean, it was trying to push me towards an ongoing truck. And it was, braking all of a sudden. It was like a complete disaster. So Europeans over-regulate. They regulate things that there is nothing to regulate on. And the Americans, of course, let people go and kill others. And we say, well, okay, yeah, it's fine. They just kill, yeah. A Tesla just killed someone, right? So that's basically what I'm after. Okay, so autonomy is somewhat different from automated operation. And I think people have used automated systems for a very long time. The cruise control system is an automated system. There is no autonomy because by definition, autonomy means AI. I mean, that's my definition, but I don't know what your definition is. Okay. All right. So basically replicate human capabilities, AGI, we've heard a lot of scary things. But the good news is all the people who spoke the past 2 days, they have no idea how to build systems. So that's the good news. So they will talk and talk and talk, and they'll have PowerPoint and, you know, Galwalk connections and this, that, and the other. But I'm an engineer and I'm interested in, okay, what is it that you're going to finally, what's the outcome? If the outcome is just a set of PowerPoint slides, I'm happy, you know, no problem at all, right? Because it doesn't go anywhere. It's purely academic. And someone mentioned that academic really means doesn't matter or something, right? So I'm happy. If academics wants to stay academic, that's fine. But then I'm an engineer and I build systems, right? Including weapon systems, may I add. So I'm saying that autonomy requires AI, but just about every successful deployment of AI has either one of two experience. It has a person somewhere in the loop, or the cost of failure, should the system blunder, should be very low, says Mr. Rodney Brooks, MIT CSAIL and co-founder, also the iRobot guy, okay? So this is the takeaway. So if you guys don't want to listen to the rest of the presentation, it's fine. This is my takeaway, okay? All right, so I'm working on assurance of naval autonomous systems that use ML. And we know that, you know, the naval autonomous systems are going to use ML. And so they will be deployed in a wide range of systems. And then for me, ML really means DL. DL means CNN. CNN means, DNN. DNN means CNN. And now CNN means large language models or generative AI. Okay, so basically that's all I care about. I don't care about any other. If you want Bayesian nets, go right ahead and do what you want. But right now, it has moved from CNNs to large language models and generative AI. So is generative AI going to be used in naval autonomous systems? Hell yeah, it is going to be used. Okay, but get used to it. Okay. And so, you know, you can use it for image class. And the thing is, the multimodal nets are what are very interesting. So you can use it for language translation, you can use it for code generation, you can use it for even conventional, you know, image recognition and segmentation and localization and so on. They perform really well. Okay, so that's where we are going. CNNs are already on their way out, right? And of course, things like LSTMs and so on, completely useless. Reinforcement learning, Jan LeCun himself said, I wasted a lot of time on reinforcement learning. Unfortunately, I should have concentrated on something else. So that's where we are. Okay, so, well, the existing approaches are inflexible, easily fooled, unreliable, and biased. And we want to use them on weapon systems. Wow. What a nice idea, right? Okay. Well, if not, the Chinese will use it. So Facebook, you know, again, I don't want to, you know, preach to the choir. This is what, you know, image and natural language processing has happened in the past few years, actually, not too far long ago. And of course, we got the GPT-3. And of course, there are also been spectacular failures. And in this one, I really think this is an alignment problem. So what do you think that picture is? And Clip says it's iPod, right? In fact, there are more recent variants now, which actually say it's an iPod written on an Apple, right? So I'm not talking about the more recent versions, but Clip did say that this is an iPod with 99.7% accuracy, and I don't see why that's a problem. But human beings think that it's a problem because, you know, it's still a Granny Smith Apple, right, with iPod written on it. So this is I think the crux of the problem that we are facing using just, you know, AI willy-nilly, is that we don't know what it is that we even wanted to say, right? And then similarly, if you have a chainsaw, you put a few dollar signs on it and it says it's a piggy bank, right? So those are the kind of, you know, and then someone said that GPT-3 is the most expensive broken calculator in the world. And there was a lot of, you know, consternation yesterday when people were talking about, you know, how bad it is that they release this into the world, et cetera, right? So, yeah. And so AI and irrational exuberance, I won't go into this. This is a woman called Melanie Mitchell, who wrote this excellent paper a couple of years ago on why AI is harder than we think. And she talks about all these fallacies, et cetera. So I would urge you to read this paper. Okay, so criticality is very important here. So if you're using AI for Netflix recommendation system, I say, doesn't matter, you know, you guys can go ahead and use it because the cost of failure there is very, very low. I mean, the cost of failure could be, in the worst case, you get so upset with the recommender system that you just throw a big rock at the television and break it, right? That's the worst that can happen. But then as you go down this hierarchy, things can become even more critical. And so that's what, so we are looking at, you know, different levels of criticality, and especially when it is cyber physical, when this AI can actually interact with something in the real world and it's the embodiment in a car or whatever, that is where the consequences are severe. Okay, so as you go down, you say more and more of no, right? don't. Okay, and or you can listen to Elon, who has the social argument. He says, "Oh, my car kills far fewer people than human beings do," which is a lie. NTSB has conducted evaluations of all the crashes that Tesla was involved in, and they said that if there was a human driver, it is very likely that those crashes may not have happened under several situations. So that's a total lie. And of course, we are under-regulating this. The NHTSA recently forced Tesla to recall their stupid self-driving whatever, and then update them with software updates and so on. But it's still a challenge. And we don't want this to happen with the DoD. Look what happened in Kosovo when we went and bombed the Chinese embassy. We got a lot of flack, right? Even though you say, well, it was really a mistake. No, so I think DoD is held to a higher standard than Mr. Musk and his Tesla cars. And of course, self-driving cars, try this, okay? All right, so what is the antidote to this? What technologies are safe and what strategies are reliable? What applications are trustworthy? What methodologies are efficient? Which systems are ready? These are the kind of things that we are looking into. So how much time do I have? 6 minutes, all right, okay. Includes my Q&A. Okay, so then I'll very quickly pause and say that this is what the roadmap really is. Okay, so I look at the overall deployment of AI in a given system under 3 categories: safety, reliability, and trustworthiness. And reliability has to do with the alignment problem, which we already talked about. The correct operation, identifying the out of operational domain is a huge problem in AI. So they say, well, it works under the situation under which it has been trained and tested. What happens if it goes outside that domain? They say, well, what if it rains? And then will the Tesla still do the lane keeping correctly? No one knows. And the detection of this itself is a big problem. So that's an area of research. Safety, of course, is provable absence of unintended functionality. And finally, explainability. People talked about explainability. So in fact, I recently spoke to a fellow who's the chair of explainability at TU Dresden. And I said, what is this? And he said, well, explainability is not even possible. So it's just a legacy, title for my chair. I said, oh, really? Oh, okay. So explainability has always been elusive. Secure and fair, there's all this unintended bias and so forth. So that, right? So the thing is, 2 can be established by statistical metrics, but 1 and 3 can only be done with logical arguments such as formal methods, which, as we know, is also flawed and kind of fraught with pitfalls. So basically, I stand by my original statement. Use of AI in X, where it matters, don't. Thank you. Any questions? Yes.
Can I don't think this is science. I think this is interesting. It's a fun discussion, like coffee room discussion. However, it's not science. Even in very, areas where you would normally think, oh, you can't measure it. For example, you have a psychiatry patient coming to the emergency room. You look on a TV show. What can you do? It's not true. There actually is science. There's metrics for measuring things, and with a pretty high reliability, you can sort of say who should be kept in the hospital, who should be given a drug, who should be given this. There's actually, a lot of things in science. We reproduce things. We make evaluations. We score things. Same thing. You gave like levels of criticality, which is good. Okay, that's good. Everything else, it's interesting. It's like a coffee room argument. I'm enjoying sitting here listening to it, but it's not science. Okay, start like even you said, okay, Elon Musk, cars don't work. It's not true. You're giving me data that's 5 years old or something, and
I'm talking about NHTSA. Recently published.
Yeah, but it's yeah, but software just got. Because version 11.4 works like a million times better than the previous versions, and it keeps changing all the time.
It's still experimental. It has not met the standard of safety requirements by the NTSB, and it's not been certified.
Okay, no, but because it keeps changing all the time.
5 nines is the minimum reliability that we need from cars. So therefore, people are going around driving these cars all over the place because they want to show 1 in a 10 million chance or something of it actually kicking the control back to the safety driver. It has not been achieved yet.
Yeah, but human beings are driving car after, taking drugs they shouldn't take. They're driving cars while they're tired. Human beings are worse. I don't know. I would think they're worse if you measure it. You need to measure things. Yeah. Mm-hmm.
Yeah. Would you have been happy that your grandmother getting killed simply because it's just a statistic? It's still 1 in 10 million people.
I'm not really a debater, but I think there's terms for this. Well, no, it's not okay. I'm saying you're wrong. It's not, because basically you're giving me an anecdotal situation, trying to make it. Okay, you're giving me an anecdotal situation. You're trying to give me an anecdotal situation to try and make me emotional and stuff, which it's not, that's not part of science too. Again, my background before medicine was like science. It's like science and engineering. You have to make things work. If you I don't know how the military design stuff. I don't think this is a good way of use. If you want to evaluate risks for AI, you need better metrics. This is not science. These are not reasonable metrics. I have no background in defense, but I can tell you right away, these are not reasonable metrics at all. Okay.
Thank you for your comment that we need better metrics. I certainly can second that. And also, thank you, Ramesh. We're going to keep collecting questions for a moment.
Yeah, I'm not sure exactly what I was going to say other than, I think that from my perspective, right, what I feel like the speaker is saying is our tools that exist today are insufficient for the problem. And I strongly agree with that. And whether there are tools from other areas of human knowledge and science that we can bring to bear on the problem is kind of a fun question to think about. But I guess that's really my comment, right? Is that you're pointing out the problem, and I agree with the problem. There might be details that I don't want to agree with, but that's okay.
Yeah, so similar arguments were made of AI, software in avionics. And so the DA-178 standard, we were throwing, really darts at this thing. And now it's come to DA-178C, and there are, processes and mesh, and so on that have some degree of reliability. But it's still software in aviation.
So can I ask you a question?
Sure.
You gave one thing, the sort of pseudoscience, Rodney Brooks definition. Okay, so like you give advice to the FAA.
Yes.
And what I'm saying, take it, in a positive way, because I think the field can be improved, and you could be the one improving it. How come? Why did they allow 737s to fly with that software? If it should there shouldn't be a horrible thing because of a blunder, or or you said that there should be a person in the loop easily, which there wasn't. There wasn't a person in the loop, and the cost.
That was called the pilot.
Yeah, but he had a hard time having access to preventing the plane to crash.
That's because they obfuscated the system's performance.
Okay.
And, decided to cheat the airlines.
Okay, so they would have.
Something which had inferior safety.
If they would have followed the rules, it wouldn't have happened.
If they had,
Okay.
Actually, this is more than that.
Okay.
It's under regulation because FAA said, Boeing, you go make up your own questions and you give us your answers, because we don't have people who are smart enough to understand the nuances of what you guys are doing.
Okay.
And this is abdication of responsibility on the part of FAA. And in fact, all the guys who are responsible for this decision have been fired.
Okay. Just saying. But anyways, I think what I'm saying is positive things. You should really apply them, and you'll have better safety.
But I'm saying no metrics and so on. That is the metric. There have been clear metrics defined. Elon Musk has not been making those metrics, and so his system is still not. And we do a lot of that.
Okay, so I applaud all respectful debate and everybody bringing their ideas to the table, and I really appreciate people holding the discussion standards high. We are here to have a scientific discussion about facts as best as we can ascertain them, because safety is really critical. And so thank you. And without further ado, I'm going to start our final speaker for the speaking portion. Next section will be, we're going to take a little break, and then we're going to move to having more of a panel discussion. right? So more voices in the room and time to get back to earlier questions and whatnot. Okay. So please introduce yourself and I'll start your time.
All right. Hi, I'm Mayank Kejriwal from University of Southern California. And I am just here to provide a few thoughts on evaluating AGI. Are we ready, right? And I do have a lot of citations in here. So before I get a critique that this is not science, all audience members should know that I was in the debate club in middle school and high school, and I am planning to go into politics. So just a word of caution. No, but all in good. Good taste. Okay, so just a few thoughts, and since we only have 18 minutes, I won't repeat things that I've said in previous presentations, and I will try to provide some new thoughts here. So when I show my projects, often I'm asked what is common between some of these, and usually my answer is, in terms of some techniques, that we use, knowledge graphs, language models, and so on. But there is something else that is common to many of the challenging projects, which is how do we measure success, and are we measuring success correctly, right? And these are important questions. Sometimes there's a good answer. We often like to go and look at the literature. We like to talk to, in the case of some of the more applied projects, to talk to the domain experts to see whether we have alignment, right, between what we are measuring and what they care about. And hopefully we arrive at a good answer. But in some projects of a more fundamental AI nature, we have found that measuring is measuring the right things and optimizing the right things are surprisingly difficult. We still don't have all the answers. So let me start with just typical AI evaluation. Everyone knows this. We study this in undergrad. High school students are probably familiar with this. You train a model, you tweak the model, you confirm results on a test set. And this seems to be an established framework, right? At least for supervised machine learning. And so on the surface, this seems like a good evaluation framework, but is it, right? I'm not saying we throw it away, but I do want to critique this evaluation framework a little bit. And, and I'll provide a couple of reasons why it may not be a really good evaluation framework for AGI problems, right? So let's take a step back in order to answer that question, that is it good enough? So first, right, and these are sort of my thoughts, but hopefully these are not controversial. So what is the purpose, right, of evaluating a system, or this is generally, I would say, any a system, but you can, for AI system, I think this especially holds true. So first, right, obtain a reasonable estimate of its performance on a representative problem instance, which typically we proxy through the benchmark, right? So there are benchmarks, ImageNet, etc. The idea is it's a representative problem instance. And so can we get a reasonable estimate of performance to objectively gauge improvements over time? This is why we want, consistent metrics, consistent benchmarks, so we can apply, right, the different techniques, but to the same problem, same metrics, so we can gauge improvements over time, and to have standards and definition as a community so that we can be reasonably sure we're not comparing apples to oranges, so to speak. All right. Okay, so in practice, I would argue that our goals have really become, first of all, right, to beat a benchmark to death, whatever it takes, not really to obtain a reasonable estimate in good faith. To objectively gauge improvements over time, I think has kind of become to show that we can outperform the current state of the art on those benchmarks. Hereby, we are really mean researchers. When we go to academic conferences, this is often the unspoken rule in a way. Especially systems becoming more complex, you get 1% improvement, 2% improvement on a benchmark, and that's kind of the positive bias in the results that get published. And to hide, sometimes you want to hide behind the standards and let the metrics optimization become the end goal. And there's a law, I forget the name of the law, but they say that once you start optimizing the metric for the sake of it, it can be easy. We're very, we have a lot of ingenuity, right? As researchers, as humans, we can really game it, and even if we're not, trying to. It's kind of interesting to sort of think about, it's like, are we that objective, right? And sometimes we think, oh no, we're scientists, we've been trained well, and we have good faith and so on. Well, I think medical science more than any other has really recognized that the human brain, right, when it really believes in something, whether it's as a patient or as a physician or drug manufacturer, etc., can result in all kinds of artifacts. So, the placebo and nocebo effects both demonstrate what the human mind can do when it believes in something. With the nocebo effect, there's a true story that is documented. So there was this person, he accidentally took a whole lot of pills, accidentally or suicidal, I don't know, but he thought they were antidepressants. And before you know it, he has physical symptoms. He's rushed to the hospital. He dies. And then they do, or no, he doesn't die, but they do a test and they find out that it's not antidepressants. He took placebos and thought that he had overdosed in antidepressants, and he has physical symptoms like the blood pressure, everything is off the scale. And then he's told that, no, these are placebo pills, and then everything goes down and he becomes normal. I'm like, that is some mind control, right? That's a nocebo effect, by the way, but for the placebo effect, there's this quote, which about a third of patients with a range of conditions improved when they were given placebos. In the original 1955 article, it turns out this was documented. So it's powerful. So of course, I have to quote Herb Simon over here. So the evaluation problem can become more acute when we start building learning systems that are meant to be more general. So what Simon said, and I think he was talking about general learning in that era, was that learning denotes changes in the system that are adaptive in the sense that they enable the system to do the task or task drawn from the same population more efficiently and more effectively the next time, right? So are we measuring this properly? And especially the next time, that phrase, more effectively the next time, I would submit is actually not what the supervised paradigm is really measuring. And the ability to perform, this is a paraphrasing, the ability to perform a task in a situation which has never been encountered before. But how sure are we that it's a situation that has never been encountered before, right? This is also a problem. Are we so sure about that? Especially given how many times we use the benchmark in so many, in a community. So, because of recent advances, I think we have a real opportunity to redesign how we think of AGI evaluation. And two problems I am interested in, of course, is machine common sense, open world learning. I've spoken about these in previous talks, so I won't, kind of talk much about this. I think these are fairly intuitive problems. And I want to just begin very quickly with the couple of very concrete kind of case studies. First on machine common sense. So, how did we initially evaluate, and we as here as a research community, evaluate machine common sense and what went wrong? So there's a paper that we published. This is a short paper, 4-page paper in Nature Machine Intelligence, where we kind of made the case that we were very concerned about the way that machine common sense was being evaluated using question answering. And we said that we need a strong test for measuring true common sense reasoning. And we laid out some arguments. We talked about common sense in cognitive science. We talked about common sense in computer science and AI. We sort of made the point that this has been a big problem for the last 40 years, 50 years, developing machine common sense. And we sort of said, first of all, the evaluation needs to be theoretically grounded. So we should not just turn common sense into whatever we think common sense is, but we need to decide on a good theory of common sense based on prior work, and then let's design the evaluations around that, right? So that we can all agree that, okay, this is what we want to evaluate on. So we kind of went into the literature, saw this theory, lots of things in this theory that said, okay, these are all the different things that go into common sense. Then we asked, are we evaluating each of these? And if not, then, like, how can we do that? And if so, then what aspects of common sense are we doing well? On what aspects are we not doing well? And so on. And then we said, well, we need to go beyond QA. So we need to go into deeper modalities, right? These can be very objective, but we need to move beyond this QA into all of these other things: comprehension, estimation, enumeration, probabilistic judgments, a whole bunch of other things, counterfactual reasoning, approximate estimation. This is similar to some of the problems we were seeing yesterday in that second grade, smarter than second grade keynote, and so on. So what I'm saying is that this is, I'm not just hand waving here. These are interesting problems, I think, of our times, and sometimes we do need to look at specific, but still big problems to understand what might be going wrong and how do we what solutions can we have? So we do think that if we are going to criticize the evaluation framework that exists, we need to provide a solution. So there are some ideas, we don't know which one will land and what the problems would be with the new ideas, but there are several ideas currently in play, and I presented some of these in the papers in the last 2 days. If you're interested, encourage you to read those, but I won't stop on those. So now let me move on to open world learning. So I did a tutorial on this on Friday. So again, I will not sort of harp too much on this. For those of you who are not in the tutorial, the problem is relatively simple. It's that there are these black swan events. There are novelties in the world. How do we build systems that in just a few time steps, ideally in one time step, can adapt to novelty, right? So this is not really so much about how we build the systems, but when it comes to evaluating those systems, again, there are some very interesting issues. So the evaluation of open world learning is a fundamental departure from current machine learning practice because the task environment, the structure of the task environment can change. And this paper on the right is from this conference a few years ago, where very interestingly, I think the phrase is interesting. It hasn't caught on, but I really liked it, which is the trap of developers' experience. So what they were really saying was that statistically, you can do all the right things. And yet, right, simply because there's the architecture that you're building to solve the problem, there are many degrees of freedom. It's not like there's one solution usually, or one architecture or one neural network that can get you to the solution. There may be several. So it's quite possible that you will somehow, because you're touching the benchmark too much, because you're looking at the test set too much, or simply because you have knowledge as a developer, you have intuition, you might feed that into the system. And this in balance, this is not a bad thing to do. But if you overdo it, right, then you're fitting to the benchmark. This is very different, by the way, from overfitting. So sometimes students ask me, isn't this overfitting? I'm like, no, not really. It's a higher order problem than that. You could not be overfitting. It's kind of like bias, there's or confounding, those kinds of problems. There's no statistical test for confounding, by the way, right? So it's a common question. There is a statistical test for effect modification. For example, is the effect of smoking on lung cancer modified by alcohol, right? That's different, right? So if you're a heavy drinker, then does smoking change the way that your lungs, that you have lung cancer? If you're a moderate drinker, does smoking affect the way that you might develop lung cancer? That's effect modification. But then there's confounding. And for confounding, there's no statistical test. There are some guidelines that you can follow, and then you have to make a decision. You have to make a judgment call and argue in the paper that is there confounding. And later on, there could be confounding, and other studies might show confounding. So this is why the science is evolving on that all the time, right? Is coffee good for you? Is the one I always, is wine good for you? Just, it seems like every 6 months there's a new study showing alcohol is good, alcohol is not good, even like moderate alcohol. So once the structure of the task environment changes, greater demands are placed on generalization. I think generalization is really obviously of key importance in AGI. And so we need to be extra careful, right? Because when we are looking at narrow problems, then perhaps we can get away with good statistical frameworks, right? And we don't have to worry too much about the high order generalization and developers bias and trap of developers experience and data set bias, model bias, etc. In simpler words, right? I mean, certainly for OWL, we have the special problem that we want to know if the system can generalize to learn towards genuinely unanticipated novelty. So genuinely unanticipated is important because if I have any inkling that somehow the developer or Elon Musk or whoever kind of are just, sort of training in a simulator, anticipating all the novelties in advance, then they seem to generalize or do well when the novelty, quote unquote, occurs. I mean, it's not really novelty, right? If they've anticipated it beforehand, but if a true novelty occurs and they fail, right? That's kind of the only way we would know, but we don't want to know that way, right? So we do need to be sure in a way that the algorithm can react to genuinely unanticipated novelty. And we argue that, one way to do this is to have this, team rolling. This is not a new concept, but we're saying that there's blue team and red team. The blue team builds the system. The red team provides some of the rules of what the evaluation will entail. So, you kind of know what you're in for. but you don't get to build the novelties, right? Some other team does that. So you can be sure it's like a double-blind, triple-blind trial, right? In medicine, we're saying something like that is needed over here. We're also arguing that we need to test for things like anti-fragility. So if you think about Herb Simon's quote, right, he kind of said more effectively the next time. And I think that one way to think about that is not doing well on the test set, but it's more like online learning that comes closer to that, okay, you learn as you go in an online fashion. But I would argue that it's even stronger than that we need something like anti-fragility, and we need to test for that, okay, if it's like the human immune system, if I make a mistake once, okay, I'm allowed to learn a little bit slower, but the next time, if there's a similar problem, structurally similar, then I should learn quicker, hopefully not make the mistake. But if I do, then I should learn quicker. And then I should learn quicker, right? And I think that that's important in learning. Maybe systems don't have that, but we are not even testing for this. We're not even talking about designing anti-fragility in even narrow AI. So, again, I presented this approach in the tutorial, so I'll skip it. But again, this is a new framework. What this is saying is let's have these kind of metrics rather than simple accuracy, etc. Yeah, and okay, so is just in my last 2 minutes, I want to just close with some thoughts. Is evaluation just a problem in AGI, or is there precedent in other fields? And there is precedent. So these are some busy slides, so I'll go through them quickly, but maybe in a discussion or Q&A, is that Q&A inclusive or?
Yeah, there's going to be lots of debate.
All right, great. Okay, so statistical reporting has evolved quite a bit in epidemiology. You don't have to read this text, by the way. The only contrast I want to draw is look at the left-hand side, right? You have numbers with standard deviations with 95% CIs in epidemiology journals. This is a paper from NeurEPS 2021. You see the table, you see the result, no sense of statistical significance whatsoever. We don't even know, is the result statistically significant? This is not uncommon even today. Other social sciences have become much more serious about statistical and experimental rigor, but there is a cost to it. And I'll point you to the quote on the right-hand side. The effect is an evolution to safer and safer projects, leaving real innovations to die, not in some file drawer, but in the thought bubbles that pop into your head as you take your morning shower. The truth is that if we over-metricize, if we become over-rigorous, if there's any such thing, if we become over-conservative in the way we do science, then it's quite possible that we'll stop being innovative. So I don't know the answer to this, but there needs to be a balance. There is a cost when you try to over-apply statistical techniques. Despite some promise, old habits may take some time to die off. I've given examples from economics. Despite Dan Kahneman and all his studies on behavioral psychology, Homo economicus, the rational man, remains all too alive in many papers. And as we solve some old problems, some new ones have emerged. I really love this article, which was published by Stanford professor. If you're looking for a more accessible article, there's this one, How Shoddy Data Becomes Sensational Research. I'll just stop here. But basically what this is showing is that we might think that, okay, if we're doing p-values and this and that and all of that, we're being rigorous. We have to be very careful that we're not hiding behind those metrics and those techniques, because we could go wrong. So I'll just stop there over here. Yeah.
Thank you. Thank you very much. Much appreciated. So we're going to take a break here in a moment. Are there any questions that we want to get recorded while thoughts are still in mind? Yes.
Goertzel's law. Anyway, yeah, so no, the name of the law that you couldn't recall, Goertzel's law. Yes. Yeah, and yes, I got a question regarding testing AGI. Isn't AGI fundamentally a different kind of system that we test, because you can actually query it and ask it, could you possibly explain your results? Versus most other systems, it's a black box and we can't actually do that.
So I think a black box can explain itself. So it's not that you have to be a black box or non-black box, but I think explainability has its own flaws. So there was a recent paper. Where it showed that there's no one definition of explanation that is a human's life. That depending on the application, different explanations can make sense to different people. So the fear that again, the human mind wants to believe what it wants to believe. So you might say that, okay, my system is doing very well, it's explaining itself well, but how objective is that? And so we do need a more, all I'm saying is, yes, you're right, but we need a new way of evaluating, maintaining objectivity. And not being under the illusion that we are making progress because it's explaining itself, because it's doing X and Y. But in reality, we are just believing that it's doing that.
So there's another problem with respect to believing an explanation to be
Yes.
accurate.
Bias, right? We have to be mindful of bias.
Yeah, so there's another issue there with believing that the explanation is accurate.
Yes, exactly.
Okay. So, is there any other questions that are dying to be recorded now? We are not going to answer any further questions now, but is there anybody else who wants to get their question recorded real quick before we kind of take a break here for a moment? Okay, we're doing pretty good. So the goal was to be finished with this section at 10:15, and it's like 10:18. So what we're going to do is, just a second, I'm just going to share my screen here for a moment. We're going to take a moment to stand up. And if you need to get water or go to the bathroom, now's the time to do it, but we're not taking like a 10 or 15-minute break because we don't have enough time, you know, to have a bunch of those during the session. So it is a good time to go get water if you need it, but just come right back, or bathroom and the such. So everybody in here pretty much is standing. So that is awesome. I appreciate that greatly. You know, it's so incredible to get to be here in Sweden at, where are we? We're so lost in our thoughts. How many people have even seen this? Please raise your hand if you have seen this. Oh, I am impressed. Being that I'm not local, I have no idea what this is. I have a guess, but do I have a volunteer, somebody who can tell us a bit about what we're seeing? Who said it? All right. Come and choose. Come and choose. You get a party favor for joining the party. Who else can tell me something about this image? Please move around.
I think it's supposed to be a gargoyle.
And I thought it was a dog.
Three of them, wolves.
All right. So I will give a prize to someone who could find some factual information on this before the end of the session. If you take a moment later to Google something or find out something about this. There's a lot of beauty here where we are that we may have missed. So do walk around, stretch your body. Like we need the blood circulating because we need your intelligence in this room. This is within 1 block of where we're standing. This is also lots of beauty here. So we are going to move on to having a panel discussion, get back to some of the questions that we had before. We're going to start with Emil's question. And we're going to kind of have, I'm going to change that from 3 to 9 to 3 to 6. Whoops. So we're going to have like 3 to 6 minutes to respond to questions. So we have names in here of folks who had some willingness to and some confidence in their ideas in this topic. Andre? Yes, please. Thank you so much for your willingness. You get your first choice of seats. All right. Simon? Yes. Thank you. You get your choice of seats also. Welcome. Come on up. Yeah. I think they'll be back when they're done with their stretch breaks. Okay. Peter. I saw Peter earlier. Yeah, in case Peter comes back. All right. So you don't have to go up there. All right. But you are welcome. Thank you. Thank you. So what I'm going to start with is having everybody just having about 3 minutes to just introduce yourself and whatever ideas you want to share so far on the topic. All right. So we'll start down here.
Okay. Hi, my name is Simon Loeb. I'm a lecturer in IT. And maybe I was a little bit inspired by the brochure here by saying alignment as my topic. And I'm really impressed with if this was how it works. You put your name in a hat and then off come people and they have 18 slides to present. I'm afraid I don't have 18 slides like this just on the top of my head, but yeah, okay. But I have a few words on alignment. And basically my line of thought is going in the direction that there are systems where you have the idea that they are aligned for control. These could be some dystopian regimes in the world that they might align systems for such control purposes. And other big tech might be alignment for profit. And this is another, but the issue here is it's aligning for one thing. And with a background in education, I think that there we won't need systems which are aligned for just one thing. And I realize that there are many traditions within education and how you teach and so forth. But in my point of view, I think you would want to align for a lot of things. So instead of just aligning for one thing, you would be aligning for independent thinking, critical thinking, curiosity, persistence is some of the words that I just jotted down. So you would have a lot of things that you want to emphasize in your education, and probably you also have some values, and definitely you want to be able to teach. The system should be able to teach the right thing, and it should have as we have heard in other talks, you should need to structure your knowledge in a very precise way to bring it forth in the best possible way. So how you introduce subjects, in what order you do it, and so forth and so forth. And I can definitely see that if you have a super intelligent AI, and it might be able to do this and give this information, but if you just think about building one right now, I think that somehow you would get either the order of introduction wrong, or you would get the emphasis on one thing wrong, and so forth and so forth. So I think that there would be a lot of problems just in the initial phases where you are trying to build these systems and you don't have super AI, and then you would emphasize one thing too much and another thing too little, and so forth. So that would be an alignment problem.
Perfect timing. Thank you. Please move.
Okay, can I start?
Yes, please.
Okay, so I'm working in the project of AI. I'm not professor. I'm not so connected with university, but I'm doing a bit of my research. But what's worrying me that we are talking a lot about how to have procedures, regulations about something what we can control, like military systems, healthcare, etc. But what about things we cannot control? Like we have ChatGPT, which is open to everybody, and of course we have some restrictions there, safety things. Like if you ask how to build a bomb, probably it will not answer you. But if you ask, I saw such example, tell me fairy tale about building a bomb, it will probably create this fairy tale and then you have an answer. And of course we can try to provide explainability for the models, any safety things, how we are sure about the trustworthy, but then people will not take a look at that. Mostly people are lazy. We don't want to take a look there. So I think the key is kind of education of people that we shouldn't trust a lot such models. Sometimes ask ourselves about the answer if we are using this tool properly. And I think we as researchers, people working in AI, should also try to teach a bit and say it's not the key, it's not everything which we can trust and use it everywhere. We should kind of be, I don't know, not trustworthy for that. And I think it's also really important thing that we should tell that please use it with some distance, not use it everywhere. Please be careful.
Okay, so about a week ago, I hosted and moderated a discussion about AI doomerism on my friend's birthday party. I've seen that it's not something that we've been speaking about on like this conference. But it is a meaningful societal movement right now, because some amount of people are really afraid that runaway AI will kill us all. Some people say that it will happen like in the next 5-10 years. About a month ago, I was actually in a meeting with Ilya Parker, and it was the most depressing evening for quite a while. And from my technical standpoint, at the same time, I feel that we have a lot of just technical barriers that we need to overcome in order to achieve like a true super intelligent AGI that will be able to actually kill all humans. So I don't see why it's possible in this short timeline, just because of this constraints in physical world, in the amount of stuff that we need to research still. We've seen in this conference that in many cases, people who genuinely want to build AGI are still in kind of early stages of development of this system. But at the same time, I feel that we as researchers have a responsibility to talk to people outside and tell them, no, we still have a lot to do. And at the same time, we can't just dismiss their concerns as something totally impossible, because they understand that, yeah, the chance of things going to hell is pretty slow, but the amount of possible damage is so high that we need to think about it. And addressing the first point from Ilya that there is no safety researchers in the world. Well, for example, there are quite a number of people who call themselves safety researchers in this community. Some of them more technical, some of them less technical, but still they are trying to do some meaningful work. Maybe we can try to educate them more about our technical issues. Some technical considerations of what might be worth investigating, what is like totally impossible in a finite amount of time, and so on and so on. So I think that's about my take.
Here, take this. I put it wrong. Okay. So are there any new questions that have come up in the audience you guys want to start with? Okay, I'm going to start here. Be right over.
Yeah, I got a new question. It's about AGI development, and it was brought to me because there's this new movie that's out there, and it's about this AI girl, right, that was used essentially to trap sexual predators. But in the beginning, the AI was a narrow AI, but like any other software system, it just maintains itself, and it eventually becomes an AGI. And it has, in its development, history of working or interacting with sexual predators. So the AI eventually says, why did you do this to me? Why did I have to develop in that such a atrocious environment? So, but this is a basic general problem with developing AGI, in that when we initially develop them, we're thinking we apply them to narrow problems, which could be very bad problems, and they eventually develop and they have in their memories those bad core memories and isn't that an ethical issue too?
Thank you. Any takers on the panel for that question?
Well, I would say that it's totally speculative thing, but isn't it something like basically giving your AGI a PTSD? Yeah, so it's like about the psychology of your artificial system and how it can, its past experience can affect its current behavior. And well, I would say that right now we're nowhere near this.
About this, and maybe we should have, I think she's called Timnit Gebru. She said that to develop some of these language models, you should have them developed on curated texts and not train them on the entire Common Crawl C4 internet thing. And I think she has a point. And I think if you have a person and you give this person a bad childhood, chances are that this person, human being, will not grow up to be a happy camper the rest of the life. And the same thing with AGIs. If you give them an unhappy childhood, so to speak, there will be problems. You could jailbreak them or whatever you want to call it, and out of the darkness of what they're trained on comes all of these problems. So I think it's a very similar thing.
Do you have any further comments on that topic or further questions on that topic? Well, You didn't have the microphone for your last comment, so you were talking about software and how and issues with software. I'd love to get that on recording.
Yes, the usual issue with software is that when we begin development, we're still trying to discover what it's eventually going to be used for, or how to build it. And so in the context of AI, it would be a narrow AI. And also another nature of software is that usually we keep it on, if it's useful, we keep it on for a long time. So it's kind of a legacy system. So with the current AI that learns from experience, then that experience will be carried over for a long time, like in over decades, for example, right? We have software systems that are at least half a century old or something, right? So you can imagine today we build an AI that is are responsible for taking care of crime, for example. So they experience all those ugly things of society. And then 20 or 50 years from now, they still have those memories.
Thank you very much. Absolutely.
Just a related comment on like life cycle, where with the traditional systems, even some software, even though the development might be iterative, eventually the idea is like there's some big final test at the end, and then it's ready for the real world. And so if you're selling me like a quadcopter, it's not unreasonable for me, like the first thing I do when I test it, to like throw it against the wall or something, right? But if it really is this intelligent system that's supposed to grow over its life cycle, you know, like a child, you're not going to throw the child against the wall. No. But you know the point that the rigor of safety and so forth should evolve over time, and the history really does matter.
I think this question has been a really good plug for what we're going to do in the following hour, in the last hour. So stay tuned on this topic in the last hour. Next question.
I'm very glad that you brought up the idea of Ms. Timnit Gebru. So I think she was an AI ethicist and working for Google together with her boss was Margaret Mitchell. Also, you know, they were both an ethicists working for Google, and she was, you know, sort of dumping on the Google's large language models, calling them stochastic parrots, and you know they are bad for society and so on. And Google management, of course, pushed back on this, and they were both fired from Google, and now they have their own independent ethics company. But I would like to enlighten the audience by saying that they were wrong, okay? Precisely for the reason that you mentioned. If ChatGPT had not been released in November of last year, we would have had no idea about the capabilities or the limitations of this technology. So it was a huge educational experience for humanity as a whole, and also pitfalls were identified. So there was one guy, you know, who actually took ChatGPT, and then he filed a brief based upon its caseload that it actually referenced. And then he, you know, so he, in his ignorance, he said, "Oh, are you sure these are all real cases?" And it said, "Yeah, I'm totally sure." So he filed the brief, and now he's, you know, in contempt. So, and things like that do happen, right? So how would humanity have understood all of this if they had kept it under the covers? She said, "Well, I mean, you know, it was well intentioned." She said, "Well, you have to make sure that you don't release these things prematurely." And I think the other gentleman, you know, who was very vociferously against this yesterday, saying that, you know, this thing is crap and it's doing all these wrong things, etc., is fine. But I think educating humanity about the pitfalls and shortcomings of this technology was a huge game changer. Well, that is true. Yes. Well, that's Tesla. Yeah, Tesla is trying to show us how to kill people.
Yeah. So, yeah. So you can have some very harsh lessons.
Yeah, totally agree with that. That education is the key in these situations.
Do we all agree on who the expert is so we can choose the one educator to enlighten us all? So when it comes to most issues of safety in society right now, we do have an agreed upon legislative body or some agreed upon educators who, whether or not they succeed, have been anointed and agreed upon to keep the safety within a certain field or area of study and whatnot. And this field is, well, for AGI, maybe moving slower, but for AI, moving very fast. And as we're moving both fast and slow, how do we make sure that we're doing it safely? Next question. I was really interested in hearing the answer to your earlier question. Do you remember it? Do you mind saying it again? Or shall I look in the notes? Okay, so we're going to just go ahead and keep inverting things. I'm going to have the panel start asking the audience questions. Here we go.
My question was about regulation for not only models, but also data set and everything related to AI, because as I said, we can have brilliant model, really good in everything, but then if we push garbage in, then we have garbage out. And doesn't matter what we have in this model. And my question is it valid to have also regulation for data set, etc., and how we can do that? That we can say, okay, this data set is valid. You can use it for medical purpose, for military, whatever. How to measure that? How to know that we cover all the things needed?
Okay, so I want to head back to the person it was originally asked of and have the first opportunity here.
Okay, well, knowing the answer is coming. Well, just as far as the regulation goes, I think the data quality is really key, especially for those safety critical systems. And I've been collaborating with National Institute of Standards and Technology in the US. And in software, I mean, maybe people here have even used their software on combinatorial coverage testing. I mean, for software itself. And a lot of people in that world feel that we could do combinatorial coverage over the data. So the data has some features, it has some levels, and we could say, oh, does it cover all the conditions we care about and so forth. And I was almost inspired to write a little note and submit as a paper here, like a warning to people in this community that a lot of regulators are starting to think, you know, if we have proper coverage of the data, first off, that's good enough, but also that should be a regulation, because then that means, you know, we can't actually bring new stuff into the data so much. It puts a lot of constraints on the change that can happen over time and so forth. So the issue with regulation is then as the thing adapts and updates, can you also, you know, are they actually constraining that and restricting the solutions? So that's my 2 cents.
Okay, I see another hand up over here. All right, I'm giving priority to new voices just so you don't think I'm ignoring or being unfair. There's a method to the madness.
Thank you. I think we also have a problem that we talk about the data in the sense of that this is, you know, a big data system where we have correlational information afterwards, like large language models. But if we're talking about AGI, I mean, we barely restrict the information that, you know, humans get. Why is that? Because we can talk to the system, we can explain to the system can, you know, sort this into its own knowledge base. So if we have a knowledge representation where we don't rely on massively huge correlational information, but rather on structures where we can, you know, maybe even introspect this and restrict this knowledge in certain situations after it has been trained, then this issue isn't really there, right? So I think we have to have a different approach, because otherwise, if you restrict the data in any way, you will always bring in the human bias, right? I mean, right now we have people sitting in Kenya going through information about racism, child pornography, and so on. Well, yeah, that's something somebody has to do. But in the end, it is always the human that puts in this information about what isn't wanted and what is wanted. And then we come back to the question, you know, which legislators do we trust to do this correctly? And, you know, that this is in the end the system that we want. So in my opinion, this shouldn't be a question if we're talking about AGI, because the system needs to get the information that is out there. And then we have to talk to the system, or, you know, interact with the system to restrict or constrain its decision-making in certain ways. Thank you.
Thank you. Oh, all right. So we have some panelists responding. did you want to get your question or comment in real quick? Okay.
So I've been involved for about 2.5 years on regulating artificial intelligence in the avionics industry. And so I've seen a trend here. So Europeans tend to regulate things that are non-existent. So I believe that there is no technology that can be used in aviation that is worth its salt because they're all very unreliable. They don't have the 5 nines. Okay, so they're statistically not feasible, but then people want to push it anyway because the Airbus wants to have a leg up on Boeing, whatever. So they are trying to regulate things that don't exist. And then the US, on the other hand, is taking a very cautionary, look at this because the FAA is sort of looking along the sidelines. They've had their, egg thrown in their faces because of the Boeing 737 MAX disaster. And so they are sort of, very, very, so contrary to popular opinion, the Europeans are the ones who are gung-ho on using AI technology in aviation, okay, as opposed to the other way around. And so they, so DO-178, this was for using software in aviation that had similar concerns, in the 80s and so on. And then finally, I think we kind of came to a happy compromise by saying that, we will have some processes and so on. So the European regulators, EASA is the equivalent of FAA on the European side. They also believe in the processes. And the process was exactly the one that Mayank was mentioning in his talk. It's like, yeah, we'll have this test set and we'll have this validation, etc. And I think precisely for the reasons that he mentioned, which is these things do not take care of unexpected events, is why that whole regulation is nonsense. Okay, and in fact, I'm a part of a co-author on a paper and a co-author on a set of regulatory standards proposed by industry for AI, and I'm going to withdraw from that because it's no longer adequate because of the concerns. Now, how does Tesla do this? Tesla actually has got 2 inferencing engines, in their car, and one of them is actually doing the control, whether when autopilot is on. The other one is noting what is going on between the predictions made by the autopilot and the predictions and the actual observation from the driver. And this happens even when autopilot is not engaged. And they take exactly those unexpected events and they send it to headquarters. And there are a team of people that are 80 people or something. They sort of look at all this. They make rules which are on top of the AI, which kind of like fix and massage these things. And then they come up with the next release. So this is to take care of those unexpected events. Yes.
I think we've got all 3 here. So I'm going to start in the middle and you can choose which side next. But I think we're going to hear from all of our panelists at this point. And I'm going to give each of you up to 6 minutes for this one. Of course, you're welcome to cede your time. But
okay, so for this comment about taking care of an uncertain explanation, prediction, I totally agree. I like this approach of Tesla, how they are doing that. But regarding this AGI approach, for me, it's still the same issue because here we have data sets and we are providing data sets. In the AGI, you will provide rules of word like physics, ethics laws, etc. And which ethic law we want to choose, the one from Europe, United States, Asia, which one is valid? And which one we want to choose for ethic laws for AGI? For me, still the same issue that somehow we need to say what we want to use.
Okay, I wanted to actually say that the question about like high quality data sets is kind of solving itself because the proper incentives are already in place because everybody who is working on AI that uses a lot of training data understands that if you don't get quality data, you won't get good product. So everybody who is gathering data tries to get the best of it already, and they don't need a specific regulation to do the good work and not produce a shit product because they just won't sell it. At the same time, especially in large neural models, we are in relation to the ethics question, we are kind of in a situation where our systems are just like modeling language, but they can't, for example, differentiate from is and ought. Like they have some snapshot of the world. We can try to tweak it so it will produce less racist outcomes or racist language, but we don't have just algorithms that would understand that, okay, in my training corpus, there are a lot of old-timey texts, but when I'm producing new text for some usage, it should be not repeating the same old text. So, and then this is not a data question, it's an algorithmic question that is still open.
Yeah, and this was a comment to these people sitting and making reinforcement in Kenya about GPT models. And I think it was easier early on where there was a model where you could just have a logit and you could have these beams of what it was producing. And if you encountered a certain word, it just stopped and you retract and make another beam and so forth. And with these reinforcement techniques, then the wrong things are still in the model. So then people try to jailbreak it and it resurfaces and so on and so on. And I think it comes back to, why are we having this model? Why aren't you doing a curated text so it can dig into something which is horribly wrong for various reasons? So it's still there, and then you can try to have this layer to protect it from going to the users, but wasn't it much easier if it wasn't there in the first place? So that would be my comments to that.
Okay, hands high. Okay, I thank you. I'm gonna go 1, 2, 3. All right, thank you, Bob.
So on the sort of questions about the regulation and stuff, it feels like to me that there's two different kinds of problems. And I just wanted to put this out there to get people's feedback. I mean, one is like Tesla collecting all that driving stuff. As long as we think about driving as a fairly static domain, no new technologies are going to be introduced that radically change the behavior, say, then it makes sense to collect all that data and to use it to refine the system over time. For the large language models, though, it seems like we got to be really careful because, I mean, we've already seen examples like I think it was Big Bench, that was a benchmark that got developed for language models, and then it was used in the training of the language models, supposedly accidentally. And so it looked really, the next generation of language models looked really good on Big Bench because it's seen them in its training. So it seems like that. I wonder whether in just a few years, we're going to be in a situation where there are professionals who are always designing the new test sets for the new algorithms that are, you know, the equivalents of the water jug problem and the towers of Hanoi and all those kind of toy problems that we think about from AI, but are the new problems, the new instances of problems that have got to be put for the generative language model. So I don't know, but that's kind of one of the things I took away from some of the conversation so far.
Thank you very much. Oh, you were just, thank you for raising your hand when I said raise your hand. Oh.
Regarding, data pruning again, I think if we want to have a system that actually understands, let's say, for example, history, we have to put in data that is, that represents racism. We have to, otherwise we can throw out all of history that had to do with racism and don't train the system on it. But I don't think that this is really a sensible thing to do. So also coming back to the ethics part, we have to decide which ethics to put in there. But do we have to do that on the data that we give the system, or do we have to do that on, how the system does, what the system does with the data? Because I would love to be able to say to ChatGPT, don't be a racist, and it just isn't, because it understands what racism is, right? ChatGPT doesn't have a deep understanding of the matter. So let's take this out. But if we have an AGI that actually understands concepts like racism, wouldn't it be way better if we can constrain it after it was trained? And it can make its own decision on whether something is racist or not, based on information which we give in the system, right? Then we don't have to prune the data. We don't have to say, well, this is good data point and this is a bad data point, because otherwise I think we will, you know, remove stuff from the training set that some people might see as very, very important just by the decision of single humans that decide on what goes in the data, right? And yeah, as I said, you know, if we don't want a racist system and we don't want to train it on racism, then we are going to have to get rid of all information about apartheid, segregation, you know, and all the racist things in the past. Well, I want a system that can tell me that this was wrong, you know, not that can't tell me anything about it. Thank you.
Thank you. Okay, I'll be right up there.
Well, just a really short thing, which is if it doesn't know racism, maybe it rediscovers racism, right?
This would be my opinion. Then the problem is that GPT-3 and 4, they don't understand anything. So they need to understand the problem, for instance, of racism. What is the problem? The problem is that if you have a body, you don't want to be judged unfairly, and you don't want to have threats occurring to you. So there are concepts there you want to understand, and you want to understand that it's bad if it happens to somebody else. Then these rules could be reversed because they are rather arbitrarily, and then they could apply to you. So that's the level of understanding you want. But if this understanding is not there, then you have these stochastic parrots and so forth. And then it's a problem that you have this. But I, of course, agree that if you need to have something in history there, then it's there. So, yeah.
Do we have a fresh question? Okay, both of you spoke before. Do we have a fresh question from a fresh face? I see one fresh face. Not to put you on the spot, but what's the best question that you can think of in
So I agree with your points that like, I mean, to filter out all the bad content from the data, it kind of gets, it's kind of like if you have a child and you never expose it to like bacteria, like the immune system just doesn't work. It has to be exposed to like bad things, and it has to be, I guess, tuned to know what is bad and what is good. So if we just remove everything that we think is bad from the data, it might create this artificial environment where like everything is good, like, I don't know, Garden of Eden or something. But I agree that like if we don't have understanding in a model, I don't know how we could how it could determine like what is good and what is bad from the data. So yeah, understanding is key.
Thank you. All right, we're going to go here and then back here.
Yeah, just to comment on that, yes, having a good immune system is critical, and it goes to the idea of you need more than just upfront cleaning up data. You need something that's reactive and adaptive. Yeah, one of the problems that we had with social media was that social media was essentially something that would hijack the immune system of our society, right? Because the social media's business model was to give advertisers or anybody direct access to different kinds of personalities so that they could target. So it's essentially adding, it's equivalent to biology of adding a vector into a body and basically penetrating their immune system. So we didn't have that in social media, and we have the chaos that we have today. So my question is, well, not related to that, but it's more related to OpenAI's current stance, which is they want to keep it private because they don't believe in the open source equivalent or the democratized version of adding safety, right? And so how do you square that when there's an intuition that we'd like to have everyone participate in the question about safety in a democratized way versus the opposite, where there are some elite folk who understand the matter better than the average folk, and should we be guided by those or something in between?
That is an excellent question. Do we have any takers on answering that question or taking a stab at that question?
I'm pretty sure that democratizing and have it open is better, because I can imagine that open we can have kind of leak of technology, how it's prepared, and again it will be spread over the world and we don't know how people are using that. So I think better is to understand and have it from the beginning and trying to solve this issue, instead of, after 10 years technology will be leaked to the world, then or somebody will just take it from them and use it in the wrong purpose. So, or they will change their mind and use it wrongly. So I think spreading through the world, this technology is better.
I would say that the question is mostly about if we should make really the most advanced system open, the most possible, the most capable system that can be used for some really scalable and influential outcomes. And for them, I'm not really sure. I'm pretty sure that we can open a lot of just earlier stage, simpler algorithms, backbone stuff. That's we can definitely open and improve and so on and so on. But about the most performance system, I would say that we shouldn't rush opening them as fast as we could, at least. I would guess it's probably fine to do some like delayed release, maybe like 2 years delay or something. Obviously, some parts of the system would already be deduced by other researchers, and maybe this is also a good thing. So I wouldn't say that we should keep everything as open always as we can. There are some dangers there also.
Yeah, I think, for instance, with these language models, people imagine all these scenarios where it produces a lot of text and contaminate the whole public discussion and everything goes haywire from there on. And of course, that's a valid point. But if society is somehow structured to cope with these things, that there are some outlets which actually give you the true information that you can trust, and you don't have half of the population getting their news information from social media where they could be exposed for manipulation and so forth, then a lot of these things wouldn't be such an issue. So I think it has to how society is structured and what the vulnerabilities are in society. And if we work on making society more robust, then some of these problems would be less in your face, Mike.
Okay, so I just want to say that I'm saving your question because it's going to be a great segue soon. So you're on my radar. Thank you. And we're going to go pop, okay?
Right. So we have an issue here that if we open up the system and we don't have an immune system, then we're going to be in a big bind. And if that immune system happens to be the best AGI that's available, right, then the only time it can really be open is when the best AGI comes out, because it has the immune system. Like right now, it doesn't have the immune system. You can hack, you can train these models, especially open source models, to whatever kind of demanded system that you want to build, right? And it's just going to spread, and it's going to spread in social media, right? We don't have an immune system in social media because the business model is such that it's anti-immune system essentially, right? So where this is all going to lead when we don't have the proper immune system or governance present today that will defend us against, all sorts of bad scenarios.
Thank you.
I just wanted to add that the concern about automating, creating like disinformation or bad content or something, I think it's somewhat overblown, mostly because people are already capable of producing like bad content in astonishing amounts, more than really people willing to consume them can already consume. So like the market of disinformation is kind of saturated.
This is the last comment, and then we're going to have our next question.
Just directly on the disinformation thing. I maybe that one is a valid point, but there's this thing called Kali Linux, which is Linux for in the good day penetration testing and a bad day cyber hacking. And now it's well known in the cyber community. You can just tune up the LLM on the manual for Kali Linux, and it can enter right into the command line itself. So spewing disinformation is maybe a little bit different than spewing, attacks. And so that's a big issue. But I also really like the point about we don't know how it's going to be used. And from an engineering perspective, I don't think the 4 or 5 or 10 or 20 great minds at OpenAI or whatever are going to be able to imagine all those use cases and play them out. And so there's also a big benefit to figuring out what those are.
Thank you. And our long-awaited next question.
I was wrong before when I said this isn't science. This is the first step in science. Okay. I went to public school in Montreal, but it was a good public school. When I was in grade 5, the teacher gave us all candles and matches and told us not to play with them. And we lit the candle. And then as the first step, we had to write, what did we see? About the flame, the color, what's happening, right? And that's the first step of science. So this is good. It's the first step. But keep in mind, people are jumping, when I saw the topic, I thought we were going to talk about some of the things like Bostrom wrote about, like, when we get to the point, like, AGI is taking over the world, etc. But, on the other hand, but which is a valid subject, Tyler's talking about, building real systems now, like how do you test the software? How do you make it reliable? Ramesh deals, he made a good comment that everybody else is just giving PowerPoint slides. He deals with reality. His stuff, it becomes the real world and it has consequences. But again, it's a different level. I think the next step is you have to specify what are you talking about? And then when you specify what you're talking about, you have to specify what architectures you're using, because it makes a big difference. It's just things don't just become AGI overnight. You have to specify architectures. You have to specify, you made comments, there's already so much like hate literature. It's true. I don't know, everybody says ChatGPT is the end of the world. I don't know, is it really? I mean, it's just because people write stuff doesn't mean it's true. Again, it's sciences, you measure things, you make metrics, you do this it's worked well, scientific method. There's other methods, but scientific methods work well over like the last couple of centuries. And I think this has to be applied to AI safety, my humble opinion. Yeah, but yeah.
I couldn't agree more. So the next hour is going to be spent trying to kind of prioritize the questions and really think about the metrics. And I think it can be so hard to talk about that with AGI, since there isn't a lot of certainty on exactly what AGI is going to be or how to get there. So I think one of the ways that's kind of elucidating for how big a problem answering that is how big a problem it is answering where we're at today. So that's, for me, part of why I understand that we'd be talking about AI as much as we are. I am quite eager to be also talking about AGI more. So I want to say a big round of applause for the people who have volunteered to be our backbone for the last hour. Thank you. Please, panelists, can you turn your head and make sure that I spelled your names correctly here? Good. All right. Now, don't go anywhere yet. I really want to say thank you. So please choose an item on your way back to your seat to take with you as a token of appreciation for your stepping up and being an expert of where you're at. Thank you. Let's give them a round of applause. So we are down to 55 minutes left. Is that correct? I think our session is done at 12:15. The time for me has been flying, right? So we're going to transition just to keep things fresh and also keep the discussion hopefully moving in a productive direction. But if you do need to get water or go to the bathroom, now's a good time. We're going to make the tables 3 by 3 by 3 by 3. So we can all be seated at the table together here for the rest of the discussion. So we're continuing to move the format. We're going to do some lateral thinking, and we're going to have a little thought experiment. Everybody's going to move where they are, so keep the blood flowing. So I'll announce a reconvening time here in a minute or two when we get set up in our new configuration. So we're taking a moment's break. So it's a wonderful thing when there isn't enough time to do all the things we want to do in a given amount of time. So one of the things we're not going to do is check ourselves against ChatGPT. But that was going to be my second phase of the icebreaker was, okay, what did we come up with the room as an aggregate body of knowledge? What did ChatGPT-3 come up with? And so, of course, any one of us can check this. And obviously, the prompt engineering is going to make a difference on what we come out with as an answer. And so this next section really kind of is about prompt engineering, but for ourselves. What questions do we most need to be answering for ourselves? But I also want to make this part of the conversation a little bit different than what we've done before by kind of reframing and resetting so we might have some real impetus or reason to take our conversation seriously and deeply consider what we're saying. So very much we want to move to clear plans with clear metrics. We need a domain space, all these kinds of concerns that have been raised at the table. But let's have a thought experiment first and kind of come together for this discussion. So the next little part that I'm talking about here is not intended as a history lesson at all. But I heard when I entered this area of research, hey, I know somebody who invented the dark web by accident. Isn't that a terrifying idea? Who in this room has ever been scared? Right? So what happens when you're scared? What happens for you when you're scared?
Well, I'm gonna deflect that question and instead of focus on what I know from the research, and that's basically that well, your senses activate and your field of vision really narrows, and so you're hyper focused on this one thing in particular that is probably stressing you out or scaring you. And yeah, it's really hard to get an outsider's like perspective on things when you're scared. Yeah.
I did not plant that answer, but it was really quite perfect, you know, and the words that didn't come out, but everything was described of it, is that cognition really changes. So cognition goes into survival mode, which all the expansive thinking, like while we're safe is when we need to talk about safety. When we're under threat, we're running or we're freezing, right? Or we're fighting. And under the current threats that a lot of AI technologies have brought, I think have increased the fight and flight kind of behaviors in the aggregate in society, and decreased potentially our aggregate intelligence, or certainly maybe some people would argue the intelligence of the conversation that we're having. So how do we go about, whoever invented the dark web, whether it was DOD or someone at Edinburgh University or both, how do we think about moving forward with confidence when we have unintended consequences in tech so often? In the 1990s, the internet was full of how this was going to equalize and create access, and it's done those things. But it's also made establishing agreed upon truths really very difficult. Narrow eye has made that even worse with deep fakes. How do we know what is even real, right? We've magnified our biases. Like, not a history lesson, but just kind of when we're trying to invent AGI, how do we really seriously consider unintended consequences? Because clearly they've happened. So our own alignment with our own intentions, and I'm going to assume intentions here are good, that we're making AGI to help humanity. So with that kind of remembering of what it's like to have our cognition decreased by fear in a discussion about AI, I'm just going to plant one extra question, which is, how might we use AI to increase safety at large? How can we make sure that our AI that we invent doesn't become the kind of, or AGI that we invent doesn't become the kind of thing that makes us stupider, but makes us as individual users smarter? And with that, I am going to pass the mic, and we can pass it clockwise. Just pass if you don't have anything to say at the time. If you have something you're dying to say, raise your hand, and when the person who has the mic will move it over. So, any questions for clarification of how or what we're doing at this point before I pass the mic? Okay.
Yeah, so yeah, just related to this, in computer science, we have this idea of pessimistic transactions and optimistic transactions. And the reason we have transactions is so that when we have concurrency, we sort of have methods to fix any unintended consequences, or actually any disparities in the behavior. So in the pessimistic case, you want to build something that considers everything up front, and the error will never happen. And the alternative approach is the optimistic case, where you allow errors to happen and you create a compensation mechanism or some adaptive mechanism to actually fix the problem. So the best case of that is like when you book a ticket in the airline and you go on the plane and they say it's full, right? Right, because they didn't run a pessimistic transaction, they just ran it optimistically. Hopefully it gets full, and if it's full, right, we're going to boot some people out of the airplane, right, and compensate them with a hotel room or something like that, right? So regards to unintended consequences in tech, right, there's this natural tendency to build up the rules or upfront. So the idea that we're going to clean up all the data is an example of some pessimistic approach to the solution, that you could actually think of all the ways that things could go bad, and we're going to set up the framework such that things don't get bad, right? But I don't think that's viable in this world of increasing complexity. You need something in the other end that is adaptive and fixes the problem, right, through some sort of higher level, I'm thinking of the word algorithm, but rule system, not rule system, but code, right? Anyway, that's my thought.
Yeah, so I agree that coming again from my software development experiences, what I would imagine is something like simulated try and error. Yes, so we in a loop kind of simulation, we are checking different scenarios and yeah, just testing. Yes, so just looking for kind of reinforcement learning method also, but directed and in a safe environment. Yeah, so starting with simply with some artificial agents or artificial objects, and learning first on this, and then moving to some more human-like environments. And yeah, this way I think that it could be could become more safer. Actually, I wanted to ask a question before, or make a comment also to this, because this is there was a very nice arose and a very nice discussion about if we should keep the data clean or do this data pre-processing for, and then there was an idea about the immune system. Yes, so I what I wanted to ask is a general question, maybe a little bit philosophical, but how we create this immune system? Yes, in our AGI model. Yes, so I came up with a kind of paradox, because to create this kind of immune system, we need again data. Yes, so because we need to base on something. So again, we need to have a data that is that need to be good. So yeah.
Like in the United, well, in, I don't know in Europe, but in the United States, there are a lot of people with peanut allergies. That doesn't occur in other countries, simply because it's an antiseptic. There's no exposure to those kind of pathogens. The body never knows how to react to to something that shouldn't harm you.
Sorry. I wasn't switched on.
No. If somebody is talking, you need to.
Sorry.
No,
Okay, but
it's okay.
I think
We'll
we could hear
remember for next time.
each other. Yeah. So again, having this simulated environment, and there need to be this mechanism like immune system. Yes, and the question for me is how to create this immune system that we are sure that it works. Yes, and so the question of basically good and evil. Yes.
What I want is a lot of papers on this next year. I want to see a paper next year on how do we start thinking about designing an immune system for AGI. All right, that's the assignment. Okay, we can't answer it all here, but I do want to make sure that everybody, so like if you speak, like if you're like dying to speak now, you can raise your hand now, but when the mic comes around, we'll skip you, because I do want to make sure we make it at least once around the table fully before we popcorn too much. Okay, I know it's hard because this is such an incredible conversation. Okay. It's your choice if you want to speak now or if you want to pass the mic. If it goes to you, then we'll skip you next year. So it's up to you.
Do you want to speak now? Sure. No, I just wanted to add a bit on that comment about the like a more general system to prevent not the biases and like harmful I guess intentions in that that's basically just reiterating the general wisdom, common wisdom of the research that feature engineering is ultimately going to lose to some sort of general approach. And I think it would really be interesting to see how we could come up with a system that would take this raw data, right, and then sort of extract the historical lessons, let's say on racism, on sexism, on everything like that, without being explicitly told to do so. Because, for example, what OpenAI did, they, at least insofar that I know, they did this great breakthrough on making a general language model, but then they basically keep handcrafting a lot of features to prevent it from being unaligned. And that's just seems like a house of cards that will ultimately have to be replaced. Yeah.
Your choice if you want to speak now or if you want to head to the corner.
I want to add something to this. That I think both approaches should work. I mean, this positive path and negative, because in our one side, we can, of course, try to prevent everything and try to clean the data, etc. But then we have this negative, and we should be exposed to some issues, harm from AI probably. But then I think it should work like we have viruses, computer viruses through the internet, and mostly we are exposed when they are spread through the world, and then we are inviting antiviruses, then new viruses, antiviruses, and yeah, it's kind of a game between two sides. And if we will hide everything now, like AI, and then open it after a few years, we will be exposed to something which there was no iterative kind of improvement of safety. If we are improving everything step by step, I can't imagine that in one day we will have no AI and then fully AGI. Probably it will become step by step, and we will somehow find solution how to be safe. But also we need to think about this negative thinking, how we can avoid some harm.
Yeah, regarding this like immune system approach, so I don't know exactly how like GPT-4 is trained, but from what I know, it's just like predicting the next word, and it's not trained to distinguish like good from bad. So it doesn't know if something is racist or not. And if we just remove all of that from the data, then it's kind of like evolving in this world that is say like this protected world, and then it interacts with people, and people don't live in this protected world. They might say racist stuff, and then it's like it doesn't have this like build up of protection from like yeah, like to just take like the immune system analogy. So the immune system like builds up a protection from like this small like negative things, so it becomes stronger. And if you never build up that like response, then like, and you get a big hit of negative stuff, then like it overwhelms the system and it crashes. So I think we should instead of just removing all the negative data, we should teach the models to distinguish good from bad, I guess.
Okay, just a really short comment. Like, I think it's like, sorry, I'm good now. I think it's like in human psychology, like exposure therapy, and like it needs to be done, I think, iteratively, slowly. You start off in more low risk environments, test it, and there will be, you'll see what the negative things come out of that, and then you slowly build towards like more critical environments. Again, this is like purely philosophical and defining what is like critical and what's more low risk, I have no idea. But I think that's like the only approach. Like you can't avoid all the, like there's going to be accidents that are going to happen. Obviously you don't want to be laid back about that, like, oh, there's going to be accidents, so what? But I think that's just, we have to accept that, and being too conservative is not good, and we're not going to progress at all. Yeah, that's it.
Yeah, I really agree with that point. I think in order to, how do we teach children what's good and what's bad? By constant feedback, by a second human, at least one other human telling the kid, that was a good thing, that was a bad thing. So if I look at, AI as it is happening right now, we have a huge amount of data sets. We train a model on this data, and then we are out of there, right? There's maybe some afterwards tuning of some parameters to do, this not or only this. But what I would see, I mean, in AGI, general intelligence will have a much longer lifetime in which it continues to learn, right? It's not a training phase and then it's a deployment phase. Will be always learning. So what we need is a human in the loop approach. That's at least my opinion. We have to have a human, or at least one human, in the loop from the very beginning, all the way through training, through deployment, that can constantly introspect the system. With children, we ask questions, we, analyze what they are doing. So then I think is something that we can easily do as long as we have a system that, can do that at all, that we don't just train it and then let it loose, but instead it is an iterative process, right? We look at what can it do. Once we build trust that it can do that correctly, and it can trust us that we give it the right information, then we can go the next step and say, okay, hey, let's extend your deployment to new areas, and we will see how it does there. I mean, this all comes down to, again, we are always talking about AI is as good as the data that we put in, but when we do this, then AGI will be as good as the society that it is in, right? So we have some massive issues there, at least in my opinion. I think we can agree on that. So it again comes down to, who's responsible for such a system to teach it. And I think that's something where ethics committees come in. Right, but we now need them not only to decide on human behavior, but also on AI behavior, whether it fits Western ethics or Chinese ethics. It doesn't matter, because everybody will have their AI system and they will teach it the way they want it to. But yeah, I think a human in the loop from start to finish is really necessary here.
Okay, so I think I will start by declaring that the ultimate alignment problem, as in creating provably creating a system that will never absolutely impossible to destroy humanity, is just impossible, because proving such a thing is computationally intractable, and the only thing we can hope to do is to minimize the chances. I feel that in this case, specifically today, the safety and capabilities are kind of correlated, because we need a system that won't fail in some unpredictable manner in out of distribution scenarios, because our current system, we know that 99% of the time we can train them overfit. 1% is unknown unknowns, and it's just a total mess. In case of humans, we have fallback systems, like we can call it system 2 or something related to it. But in cases where we're not familiar and don't know what to do, we can at least try to reason about what's going on and what to do. So I feel that if we'll try to create systems that can actually reason in such unpredicted situations with more logical reasoning and like all the related methods, they would be both more capable and more useful in real world and ultimately more safe because right now, as in autonomous driving, we have cases where we're not sure when the system might fail, but we're sure that it will fail not in the same place as human, because like our roads, our legal system is designed around failure modes of humans. That okay, we fail in the dark and so on and so on, but in case of autonomous car, it can suddenly forget that there is a tram right next to it. But if we'll design a system that has more like model of the world, more logical capabilities, it shouldn't use them like all the time because it's just inefficient. But trying to develop these capabilities may also make them safer in the long run.
Nice. I kind of agree with that. Actually, there were many good points, and I'm trying all the time to structure that basically in my head what we're trying to do here. And I think this is maybe kind of a problem too, because we kind of talk about AI in a general sense and what machine learning is doing and what like ChatGPT is doing, which is not AGI, which is just AI at the moment or just machine learning. And we have tools already for improving technology and introducing technology into society, and we might not want to overthrow them just because we're trying to do something new. So we should probably differentiate between talking about machine learning and the AI we have like ChatGPT and the speculation we're doing on AGI and super intelligence and something. And I think from this differentiation then results what we should probably do. Like if you want to train a general agent, it might be actually reasonable to train it like the general agents we're currently training, which are like children, and then say, okay, we expose you to everything, even the bad stuff, and you have to learn yourself to sort out what's good and not good. And if we have stuff like ChatGPT, it might even be suitable to restrain the data set and say, okay, this is not going to be a general intelligence. It has no understanding of what it's actually doing. So we have to modify over the data set. And in the end, probably the approaches we already have to introduce technology, what we did with those technologies also are the best we can do, because we just like humans and do what we do best. And we should probably not try to do like a new method to introduce the technology, but be more aware of the issues that can arise. And this is probably what we should more talk about, like what should we look for issues, but we will run into issues. And I think it's probably important to run into the problems we will encounter, but we will probably not avoid it. And this, I mean, the whole discussion is based on this: are we really ready to do trial and error with something as important as AGI? I think this was like this philosophical foundation where it says, okay, we should maybe not do trial and error because it can have detrimental consequences. But we are not really at this stage right now. We do not have general intelligence as humans do right now, and these consequences are, as far as I know, just relevant for superhuman intelligence, right? So we should probably not focus on that, and just on the methods we use to, and improving them for the problems we're seeing, and we're seeing problems and we can work with that. I mean, we can work with the stuff that ChatGPT is producing. Yeah, that's just my take.
So it's going to be really hard on this side of the table, like Felix was saying. There's so many interesting things to respond to. So I think that our first goal was to say, what are some things that AGI could be used for positively in society? And one of the things that I was thinking about is I've been rereading the Asimov robot novels, and just the notion of having GPT in my life at the same time that I'm reading those novels, and just thinking about the way in which smart, reliable, human level capability could improve the productivity of humanity. It's just really kind of amazing. So I'm really excited about that possibility, you know, even given all these concerns we've expressed today. Carlos, is that right? Carlos mentioned this optimistic versus pessimistic notion of in computer science, which I was not familiar with that notion in transactions. But I think that we live in a society, at least in the US, we live in a society where there's definitely a payoff for taking the optimistic approach. And when you screw up, maybe you don't have to pay for it, right? And so they're seeing that a lot with some of the tech companies. So from a societal perspective, one of the things I was thinking about, my spouse is a biologist. And one of the things that happened during the Human Genome Project in the US was that they said, well, once we really understand the human genome, then there will be things that people want to do with the human genome. And so they mandated through the single big research institution in the US that, and I believe Europe did the same thing, that some significant fraction, I think about 10% of all the research that was going towards the Human Genome Project was actually put towards bioethics and people who thought about that. And I don't know the details and what's been paid off, but I happened to hear a story just in the last week or so about, well, there's virus printers now. So there's, a 3D printer where you can print a virus, but built into that technology is a watermarking technology, because somebody somewhere along the way said, we want people to be able to create these viruses, but we also want to be able to understand where they came from. And so I don't know how to do it. And I'm curious what everybody's good ideas are, but, if we could think about societally, systemically, how to include in our research and our funders' priorities, notions of thinking about these problems now, so that when the real AGI happens, we're not in that opportunistic or optimistic place of saying, okay, it's going to break stuff. Now, what do we do?
Okay, well, lot of good comments. Carlos is looking at me with my mask. I'm not going to, I won't say much. I don't think, our brains work by analogies. So analogies are always tempting, but they're not accurate. Like, for example, I don't think it's good to expose a kid to Ebola virus, to strengthen the immune system. Just saying, it's the analogies fail. But anyway, it's not. I think there are two good points. One about humans. Humans have been around. We have 10,000 years of humanity, and there have been good humans, bad humans, crazy humans, and somehow we've survived. And which is a good thing. And there's bad parents, but most parents are good. Most parents, try their best with their kids, and I think that's a really important point. And I think the point about tractability is an important point also. It goes to the heart of science, like I'm saying. It's easy just to talk and talk, but then you have to say, I don't know. Cody's like an expert on looking at, our system's going to work. I don't think it's, even if somebody comes up with great techniques, I do not think you can test, a 2 trillion parameter system for what it's going to do. So basically, and no, I'm not giving any recommendations. I have no conflicts of interest because I no academic thing, no commercial, but I'm just saying, I think alien AGIs should be banned. They shouldn't be. There was a nice presentation on alien AGIs at the conference. No conflict of interest. I'm saying that sarcastically. But I'm saying I think alien AGI should be banned from, airliners, from weapon systems. There should be human AGI. You have a big advantage. One, it's based on the human brain. So basing something in the human brain is we have 10,000 years of experience with it, dealing with the problems. Two, it's still theoretically, yes, intractable, but it's much more tractable, in terms of evaluating it. Humans are much more, we have experience, if you do this and this, you expect this output. I know theoretically, not 100%. There's ways you can constrain things to make it much, much more tractable. So my recommendation is to avoid the whole AGI safety issue, ban alien AGIs, and everything has to be natural AGI.
Okay, well, I thought I knew what I was going to say, but then there's more and more comments. So just try to go through what's in my head. I mean, well, to the point about the watermarking, I think the whole digital identity and other stuff going on in computer science can help a little bit. And related to that is, again, speaking as engineer, there's this, most societies have professional engineering licenses. And if your bridge collapses, there's a big consequence for that. And as strong as that is in the US, for some reason, a lot of software developers call themselves developers, because if they call themselves engineers, then they need a license. So there is something in the AGI or AI development, AGI development, where there should be some kind of licensing process for companies and businesses who want to issue that kind of stuff. It may be related to the alien thing, because it might be a non-alien AGI might be a prerequisite for this. But and this, especially this next thing, which is like, if it's really AGI human level stuff, when we make mistakes, like in the US society, Western culture, we usually have the jury of our peers and we go to court. And actually, like in the US, at least, I don't know about other systems, but if one person won't convict you of being guilty, then you can walk free. So I'm just curious, like, should these systems be regulated by the FAA to some extent? Maybe like a Tesla-like system, if it has enough reliability, there's no court for it. But if it's truly a human like AGI, should it be a jury from society who can shape what the consequences are for it going wrong? And in that case, should it be similar to humans, where only one person can stand alone? And maybe that's a Western kind of thing. And I don't know, in China, I know they don't have the jury and that kind of thing. But the governance structure maybe actually could be similar. And in that way, it gets a little bit worrisome, because you can get away with a lot as a human, right? So what should the standard be and that kind of thing? So that's my thoughts, the ones I can gather.
Yeah, and I probably have the same problem, that a lot of things that I would have liked to mention is already mentioned. So I just jumped to the thing about narrow AI and broader AI. And I think the general public don't understand when they see GPT that this is not really understanding anything. So there is this labeling problem with what comes out. And the problem here is that it doesn't understand anything. And if we should really trust it, then there should be some understanding in the system. And currently there's no understanding. And do we have an ideas for moving forward with really understanding anything? And if this is not the case, then we have these Nick Bostrom scenarios where it turns the world into paper clips and so forth. And so I think labeling things correctly, and this is not in the interest of big tech to label things correctly, saying that this doesn't really understand things and play down what it really does. Instead, it's played up in the public, and this creates misunderstandings of what it really is. And that in the end creates safety problems. So labeling things correctly, I think, would be a first step. But yeah, just a comment.
I have no comment. Okay. Well, I am going to have the last word, and I love having the last word. So mine is all about pessimism, right? I'm a huge pessimist. So the prediction is impossible. Okay, people do say that, oh, Jules Verne and, Archimedes and so on. Also, Thomas Watson Sr. very famously said, I can see the world having a market for 5 computers at most, right? And then guess where we are? And I myself was a harbinger of disaster, because we were at a point where we were actually going to commercialize the internet. So it was an NSF project at that time. And I said, the internet is never going to fly, right? It's never going to work, because we had X25 and we had OSI and all that, and that completely fell apart. And then I had to eat crow and go to those goddamn guys at UC Berkeley called IETF, and then sort of start working with those people. RFC, what kind of an idiotic idea is that, right? So everyone's predictions can be wrong. Okay, that's number one. And the other piece of bad news is activism is not going to get you anywhere, right? So although you would like to see certain things happen, etc., no one's going to listen to you, including Elon Musk, who wanted to put an end, at least to pause, 6-month pause to GPT-4 and other technologies. Guess where that went? Nowhere. And hate to break it to you, I mean, here in our own, this backyard here, Greta Thunberg's activism has yielded some results, but mostly it's been pointless, right? So activism is not going to work. So none of this is going to work. So, but then of course, Ilya brought up this interesting point about my friend Paul Syverson, whose paper, groundbreaking paper, was what is responsible today for the dark web. So asking Paul, do you feel any remorse? And he's like, no, not really, because, we had good intentions and of course it can be misused and so on. He does not seem to have any regrets or losing sleep over what he unleashed on society, right? And I think the same is going to be the case with other technologies as well. If you ask George W. Bush about his, attempt to go and, dethrone, to attack Iraq, do you think he has any remorse or regrets? I highly doubt it. He's happy, painting and so on. So there are no, so there are no consequences for actions that will lead to, unnecessary, unneeded outcomes, nor is there a way to predict what is it that's actually going to happen, right? So that said, I have 24 seconds. And the last word is, I'd like to stand up and applaud Ilya Parker for her amazing ability to organize this workshop. And so everybody, please give her a round of applause. Thank you so much. And so is that going to be the last word? I don't know.
Unlikely. But thank you very much. So what I've asked online is that came out here was, what are the titles of some of the papers we want to see in the future? I'm imagining the title to the paper that you want to read in the coming years. And I'd like to give everybody just like 1 full minute to think about really on this topic. What paper do you want to read? What do you want to have coming out of, if it's not something you could do, what would you want someone else to write for you, right? So I'm going to give everybody just 1 minute. If you don't have a paper title, you can just pass the mic. All right. If I wanted to start someplace random and in the middle.
So I don't know about a specific title, but I would definitely like to see a paper in the AGI conference that was about methodological approaches to AGI that ensured that the AGI's psyche was being protected.
I guess a staging system towards AGI safety.
I was intrigued by the point about how Tesla gaming the reliability statistics by encouraging people to drive in really safe scenarios. So I would be interested for a kind of study of how those reliability metrics can be gained by AI and approaches to address that.
And I would like to see a paper on understanding and simulation. So the AGI should be able to simulate something and understand the consequences of it.
Yeah, I would like to see in 2 areas. One, to understand what makes animals, humans friendly, the underlying principles, and can we put this in machines somehow? So just very fundamental understanding, and then how this could be engineered in AGI. The second thing is to have strong respect to the traditional aspects of engineering, safety, regulation, standardization. And these 2 approaches could be what I want to see in coming studies. Yeah.
Yes, I think one problem that's intrigued me in the recent past is the embodiment. So one of the reasons why people think GPT-3, et cetera, are not working is because they don't have an embodiment and there's no feedback. So for example, the tactile system, if you don't have feedback, you can never grasp this cup because it's based upon the tactile feedback. So embodying AGI in physical environments, and also having that feedback, which will maybe make the next leap into the real AGI versus this pseudo AGI, is what I would like to see in terms of research directions as well as papers.
Okay, a paper that I want someone else to write, not me, right, would be the emotional and psychological consequences on humans after they're abandoned by AGI. So we have at least a year of examples of that.
So getting back to my idea, so something like distinguishing good and evil in a human sense as an intrinsic feature of AGI.
I would like to see something about what would be the AGI, because we are mostly saying that it would be kind of superhuman which is doing only the right thing. But what is the right thing? Is it take care of environment, about humans, about what? Because for me it's not obvious, and from environment point of view, probably AGI will kill us, obviously. So yeah, how we imagine AGI, how we imagine that it will be superhuman, and why we imagine that, for me, it's not like we can say AGI is solution for everything. I think it's a big mistake.
I think I would go for two things as well. One of them is a paper about a proper knowledge representation that is 100% white box, no hidden corners, none at all. And that can be implemented from all the way down, sensor data, data input streams to high-level reasoning. But I mean, that's kind of solving AGI. And another thing is a paper about the perfect seed, because we need to give the system some grounding information, right? And I would love if, maybe not myself, but people would think about what is the seed, and what do we need to give the system in advance?
There are many great ideas, I think. I would add two ideas for the conference and maybe for the papers as well. I'm sure the papers are there. So the first thing is that there was one paper and one talk trying to divorce cognition and computation, and then the other sort of trying to marry them back together, right? And in that regard, I would like to see more maybe papers on cognition, so not necessarily from AGI researchers, but researchers in neurology and that kind of science, to sort of give an overview of what's happening in the neuroscience, so that the AGI researchers and AI researchers can sort of keep up without having to delve deep themselves in their own time. And the second thing is, I'm not sure if that's even possible, but there are many people saying that ChatGPT doesn't really understand anything and it predicts the next tokens, and that probably is the case, but it feels like we're lacking a bit of a clearer definition of what understanding is, so that and that's like a huge battleground, because Sam Altman is going to tell you that, hey, we threw this C4 and whatnot on it, and now it understands, and then another person is going to be, no, it doesn't. And so maybe there's some sort of framework in place to be developed in order to qualify the systems like that. Yeah.
I guess for me, like, this kind of adds on to this, but like removing human bias in like building AGI systems and making it as general as possible, and maybe democratizing it in some way. and the geopolitical effects that come with that. I don't know, that is fun to me. But yeah, democratizing the building of these systems and like giving feedback to it and improving them. Yeah, that's it.
So I would say two paper titles. The first one would be why AGI will not kill us, and the other one would be like towards a ethical framework for AGI.
I was thinking that your second paper would be why AGI would kill us. Okay, so I would like to see and probably write a paper about lifelong learning of abstract relations and concepts.
So I'm not sure if this already exists or not, but I would wish for a paper which is more like from a technology, science side, innovation side, analyzing what was the process in the previous time we had for introducing problematic technologies and how we dealt with that and what were the issues and how can we transfer this to AI or AGI in general. And then we can talk about this democratization making actual sense, or to reduce the pace of the development, like for bidding development, maybe like with human cloning or stuff like this. And this should probably then be a series updated every year when a new iteration of GTP 4 or 5 comes out, and then we can try to extrapolate in this paper all the time.
So there's, yeah, sorry.
I'll take one as well. I'd like to see a paper on basically on how to ensure that the average person, like the common man, who is not involved in the scientific side of AI, but how they would get involved in like getting their opinion on the ethical side of things. I think that's maybe I'm just unaware of it, but it feels like kind of skipped right now.
Thank you so much, everybody. The last 3 hours have been incredible. I didn't see anyone snoring. I didn't hear anyone sleeping, right? I'm sorry, what'd you say? His. I want that paper. I don't remember the exact title, but can you say the title of the paper again? Do you remember it? Yeah. What makes artificial generalized intelligence friendly? When we answer that, I think we'll know what makes any intelligence friendly. And I think we'll all be a lot smarter. So that's definitely, yeah. I don't care what you title it. That's the paper I want, right? Artificial wisdom is a coined term here. I'm good with that. I am good with that. So there has just been so much incredible contribution and engagement. I have some more prizes that haven't been given out yet. So I would like to ask, who is the person with the least experience in the room? If you don't yet have your PhD and you engaged in conversation, all right, which one of you is the least educated? Okay, we've got 4 here. So who's in their undergrad? Okay, which one of you is the, oh, all right, you both get something. All right. So your choice, and hand me back what you don't choose. The opposite, for bringing wisdom to the room. Who here is the furthest along in their career? Nobody's copping to wisdom of the organic variety? No, it means years of experience. I would like to honor the years of hard work and dedication that you've brought to get you to the table here. Nobody has to cop to that. That's fine. I'm going to say, who here is the most painfully shy person? Who here thought it was like horrible to have to speak? All right. Okay, choose one. Okay, And then I would like you to award this one to somebody who you really appreciated hearing today.
Maybe somehow controversial, but
All right. And this concludes our session. Thank you so much, everybody.
I earned this one. Oh, yeah.